हेलो मुखर्जी सर।
हाँ मॉर्निंग सर।
मॉर्निंग सर, फर्स्ट सेशन मेरा ही है।
हाँ सर आपका ही आज फर्स्ट तो सेकंड दोनों ही है सर आपके।
ओके, तो 10 बजे स्टार्ट करें।
अच्छा 10 o'clock।
ठीक है, फाइन। एंड सेकंड होगा 1:30 पे।
1:30 to 3।
ठीक है, फाइन, ओके।
ओके।
हेलो निकिता, वॉइस आ रही है मेरी? हेलो
Yes, madam.
Morning, madam.
यस, गुड मॉर्निंग, गुड मॉर्निंग। यूट्यूब पे, ओके। So wait for a while, we are starting. Okay, let the other participant to join.
Hello, hello. Good morning, sir. Good morning, ma'am. Oh, I think.
Yes. Yeah. Yeah. Good morning to everyone. Okay. So I, Dr. Usha Tiwari, welcome you all in the day 3, session 1. So today we are having our speaker with us, Dr. Amit Sehgal. He is Professor, Department of Electrical Electronics and Communication Engineering, School of Engineering Technology, Sharda University. So before starting the session, I'm just giving the brief introduction of Dr. Sehgal. So Dr. Amit Sehgal, he is PhD in Electronics Engineering from Dr. APJ Abdul Kalam Technical University, Lucknow. He completed his MTech in Electronics and Communication Engineering from Guru Nanak Dev Engineering College, Ludhiana, and BE in Electronics and Communication Engineering from CR State College of Engineering. So he has more than 20 years of experience in industry, academia, and research. He has contributed to several research and development projects in the field of wireless networks, health informatics, and IoT. So including with corporate and international academic collaboration. Several projects guided by him have received project grant under various state and central government schemes. He is voluntary startup mentor for Atal Innovation Mission Incubator and Atal Tinkering Labs, and he is having been contributing to the startup ecosystem by mentoring innovators and early age startups. So on completion of his Cambridge certification for international teachers and trainers and Dale Carney certificate for high impact teaching skills, he made significant contribution to the pedagogic uplift of engineering education by serving as master trainer for Mission 10X, a faculty development initiative by the Wipro Technologies. So for more than 2 years, uh, yeah, so he has more than 35 papers in journals and conferences. His research interests include wireless network, remote monitoring system, and IoT. He has mentored several student entrepreneurs and has wide experience in the field of innovation and incubation. His research interests include wireless network, IoT hardware, and incubation management. So today, sir, he will basically deliver the talk on the title Embedded System Design and Hardware Integration. So over to you, Dr. Sehgal.
Thank you very much, ma'am, for such a detailed introduction. I'm able to share the screen. I hope the camera is not required.
No, it's not. It's not mandatory. Are you able to share the screen?
Yeah, I'm able to share the screen, but I hope the camera is not required because the video is disabled. I hope that is okay.
No, sir, no, it's not required. It's not mandatory. You share the screen.
Okay, fine. And
Sir,
my
it's
screen
visible.
must.
Yeah, it's visible.
So good morning, everyone. So once again, thank you very much, ma'am, for such an introduction. And thank you very much to Dr. Ashish Gupta, Head of ECE, and Dr. Parmanand, Dean of School of Engineering and Technology, for giving me this opportunity of interacting with all the faculties and students. So I'm sure that we have both the faculties under FDP, and there must be some students and research scholars. So as my topic has been introduced, that embedded system design, hardware integration. So I will be talking a lot about hardware. This entire program, the 5 days event, is mainly focused on wireless networks, wireless sensor networks, and IoT. So IoT, Internet of Things. So things is the one major major component if we talk about overall IoT system or all the application domains of IoT. So these things are something related to hardware. Fine. So without hardware, you cannot really make a system, or the things do not have any meaning without the hardware, right? And then the software is something which makes it really operational. So both the things are important. But will mainly be talking about hardware, taking you through various components which are there in an IoT system or an embedded system, automation systems, and then we'll try to have some hands-on I'll be giving you some tools which you can use, whether you have the actual hardware available or not. So how you can do some hands-on practice for developing embedded systems, and what kind of different components, different sensors you can use. So I'll be taking you through some part of it. So in the first session, so we have 2 sessions today. In the second session post lunch, we will be talking about some advanced components where we can really integrate our system, making it a part of the entire IoT system. Okay. So I'll generally start with some of the images, or you can say some quotations. So this is what you see on the screen. So 3 different statements by famous people, and spread across, you can say, maybe around 3 centuries, 17th, starting from 17th century. So this was one famous statement made by Henry Ford: "A chicken in every pot." So that was maybe the time. I'm not much aware of the history of that time, but that might have been the time when this chicken was very popular. It is popular today also, but of course because of bird flu. So we have, everybody is talking about chicken these days, but it was popular. Then things changed, and then Bill Gates, everybody knows about, is a famous personality. So he made a statement: "A computer on every desk and in every home." Right. So that was the time when the computer was becoming popular. And if somebody knows the history of computer, the first computer when it was made, so it was a very huge budget project. And the company which made it, they said that let's see, maybe we can sell one of it. So they were expecting that NASA would be willing to take this machine, huge machine, at very high cost. And they said that, okay, let us see, let us make one thing, and at least we can sell this one piece, and then we'll see what happens. And we know that what is happening to the computers now. Each home is having multiple computing devices today, and in the current situation when everything is going online, so everybody, starting from small kids, primary education, to research scholars, or to all professionals, everybody is using computing devices. So that is how the world has grown. So what Bill Gates said, that a computer on every desk in every home. So we have multiples of these now. And then now what we are talking about is a computer in every pot and every chicken, right? So it's not about having desk and home. So this is how the IoT concept came into picture. So IoT basically says that whatever you have, whether it is living thing or non-living thing, almost everything is going to have a computer. So instead of IoT, Internet of Things, so there is another term given by Cisco. Cisco is the world leader in networking devices. So they coined another term. They call it as IoE, Internet of Everything. So they say that not only things, but whatever is there in the world, everything is going to have internet into it, right? And that, of course, requires a computer also, because you need some computing and communication devices and processing systems. So this is how the world is changing from the 17th century to the 21st century in which we are. That we started with chicken in 17th century, and we are again talking about the chickens, but in an entirely different sense. So this is the story about the IoT, that how the technology is changing fast. And this is something you might see once we have the real IoT deployed everywhere. So you might be getting these kind of funny responses in your system when you open your system and your cat checked in the litter box. So because your cat is carrying a device, it is having some tracking device, and you're getting an update that what your cat is doing. So cat is very popular in most of the European and American companies as a pet. Fine. In India, I don't know that it might not be that popular, but yes, in those countries it is there. So you might get an update. Your microwave just heated a lasagna, right? So what is being cooked in your microwave, in your kitchen, or in some other devices? So you might be getting those updates. Then what you have done at your home, so you might be getting those updates. So your window must be having a sensor, and it is tracking your behavior. So this kind of applications, we saw one session about elderly people. So tracking the activities or behavior of elderly people, or maybe some other cases. So even your windows, your walls might be tracking the behavior or the work of the people who are there inside a particular room. So this happens. Your couch likes your microwave status update. So your things are talking to each other, right? So this is the real IoT, where it is not only about we sending some commands or controlling some devices, but the devices are talking to each other. And we have seen many fiction movies where your robots or your machines, they are communicating with each other, and start to control the whole environment, right? So it's raining again, you get, and this is common now, right? You get weather updates, and 15 of your things are broken. So your important items are having some sensors, and the moment something breaks down, you get an alert that something is broken. You may not be at home, right? So you haven't left house in 5 days. Okay. So you are being tracked every minute. So what are you doing? Where you are going? So this is the future. So some parts have already been implemented, and some you might be seeing in the coming future. So this is what is called the IoT, Internet of Everything, right? So whatever you see, whatever you have, everything is connected to internet, and everything is communicating with each other, and you are getting information about whatever you have, right? So there have been some famous advertisements also, like your refrigerator. So once one particular item in your refrigerator has gone below a minimum quantity, so automatically it will send an order to your famous delivery store, and you will get the item delivered to your home. So these kind of applications are coming up, right? And this is what we should think about, and this is what we should try to build, because that's the need of the hour. Right, so coming to the introduction part now. So we are talking about IoTs in this entire program. So we are in a stage of fourth industrial revolution, and I'm sure you must be aware of the first three revolutions. So it says that unlike first three, this is not a new technology, right? So we are talking about IoT, and IoT is not a new technology at all, right? So what it is an integration of existing technologies. So I don't know if we can communicate with the speakers, or maybe at the end. Otherwise, I would have wanted to take some inputs that can somebody make some comments on this, that how the first three technologies were about the new, first three revolutions were about the new technologies, but IoT is not new technology. So can somebody comment on this? Would somebody like to say? Have you allowed unmuting to the participants? Ma'am, can you confirm, are the participants able to unmute themselves?
Yes, sir.
Yes, sir. Yes, sir.
Okay, fine. So would somebody like to comment on this statement that first three revolutions were about new technologies, but IoT is not? Because this is one major limitation which I find in case of online events, that we don't exactly know what is happening. So any comments if we have some online people?
If you want to give any comments, please raise your hands, or
okay. So let me just
unmute your mic.
First three revolutions. First industrial revolution was about the steam, generating the steam, and getting the steam engine and the machines. So that was a new technology. Then second revolution was think about electricity. So you were able to generate the electricity. And then third revolution was about computers, when we got the computers. And so everywhere you were having a new technology introduced, right? Whereas this IoT is not talking about anything new. We have the computers, we have the communication systems, we have processors, electronic components, semiconductor devices, everything is there. So all that IoT does is integrates all these technologies with lots of software, right? And then that integration is what we say that it is IoT. So this is what Industry 4.0 or Industrial Revolution. So it's not a new technology. You don't need to learn anything new to become an IoT expert. All you need to do is have expertise in any one of these technologies which are being integrated, or maybe you can become an integration expert also, right? So that is how the IoT is being developed. So these are the major building blocks of an IoT system. So you have actuators. So these are the devices which are operating your things. Then you have the sensors. So the sensors basically more of a transducer kind of things. So you are getting the information about the physical parameters. And then you have a connectivity. So it can be wired or wireless. Generally, it is wireless preferred in case of IoT, because you want to keep them mobile. And then a lot of computing and processing devices are required. So microcontrollers or processors are required depending on the application. There are various options available, right? And because of this integration, before IoT, there was another more common term, and that was known as cyber physical systems. So even now it is used in some cases. But before this IoT word became popular, the cyber physical system was more commonly used. So it's not something new, something which has been developed in 3, 4, 5 years. So even in 2010, maybe 10 years back, we were talking about cyber physical systems, and things were developed based on that. But now this IoT has become more popular, right? So these are all the things, and a lot of hardware is there. So we'll try to study about some of these parts, more focused on the microcontrollers and how we are able to configure the hardware for connectivity, how to provide the connectivity, how can you connect various sensors, and how can you send your responses to the actuators. And one important thing which I would like to mention here is that your sensors and actuators, they should have a two-way communication. Then only it becomes an actual IoT. Otherwise, it will just be an automation system. You are able to control your actuator, that is fine. But whether you are getting some response back from actuator to your processor, so and the data which is being generated, how you are processing that data, right? So all these things are required to be integrated, and then only it becomes a IoT. Otherwise, it is difficult to differentiate between a standard embedded system and an IoT. So this is a general architecture of IoT. So cloud is a very important part. Almost everything today we see is on the cloud. Very heavy applications, big softwares. So you don't need to install them. You can directly use them from the cloud. So we have the sensors, the hardware part. Some of them directly can connect to the cloud, or some of them may need a gateway because of change of the protocol in between. And then all that software, so data integration, big data analytics, then real-time analytics, machine learning, artificial intelligence, all these things that you see talk about or listen in various sessions. So everything is actually implemented at the cloud level. So you are not really doing much of the data analysis or processing at the sensor level. So there is some pre-processing to transmit the data, but most of the work is done at the cloud level. And that's why this cloud computing is one of the very important part of IoT. And then you have the user end applications, apps and dashboards, online dashboards through which the users can interact. They can see the data, or they can send some commands, do the control part. So these are the three major parts: your sensors, your cloud, and then the user interfaces. I'll talk very briefly about the cloud, why it is important, because once you're developing an application, so the application engineers, so their role changes a lot when we are going from the simple standard interface without the cloud and to a cloud-based system. I can see some hand raises. Are there some questions in between? Or these are some general queries?
Sir, Dr. Abhishek Sharma has
Yeah, the
asked.
participants who have raised their hand, I think Pradeep
Sir, there
Sinha,
are
if you have any query, please, you can unmute and ask, or we'll take it at the end.
Good morning, sir.
Yes.
Okay,
Hello.
might be by mistake.
Good morning, sir.
How it is
Can you
changing
listen
the
my
things?
noise?
It is changing the role of an application developer. So if you see the first part, the traditional way the softwares were being developed, so
Amit
almost
sir,
everything is being managed by the application developers, the people who are developing entire software and other things. Whereas in case of cloud, so we have these three different forms. So we can have an infrastructure, or it can be a platform to build your applications, or it can be a complete software developed and available as a service, right? And in both the cases, what is managed by the developers and what is managed by the cloud service provider, so those things change. So when we are talking about the infrastructure, so in that case, the final main application handling the data, the runtime operation of the system, the middleware, operating system, so all these are available at the user level, the developers level, whereas the cloud is providing you the servers, the storage, the connectivity with the remote devices or remote applications, that is the networking. So this is provided through the cloud. Whereas if you're using platform, an entire platform as a service through the cloud, so you just need to worry about the application and data. So you just build your application using your controllers, implement your logic using any programming language, manage your data, and rest all is available at the cloud. So it is provided by your service provider. right? Whereas if you talk about software as a service, then even your applications are available on the cloud. So you just build some applications and deploy them on the cloud, or maybe there are some libraries, some pre-built softwares available. You just have to use them, call them in your application, and even your data, everything is being stored at the cloud. So you have nothing really at your hand. You don't need to worry about anything. Just utilize the services available at the cloud. So this is how the role of the application developers is changing, and that's why I say that when you talk about the software applications, so it will mainly depend upon what kind of cloud you are implementing, right? And then only it will be decided that how your IoT system will be deployed. So you should have a basic understanding. Anybody who is working on IoT systems, so they must have a basic understanding about the clouds, about the cloud computing, so that they know that what all they need to develop and what all they can use from the cloud. Coming back to the hardware.
Amit sir, Dr. Abhishek Sharma is having
Okay,
a question.
so why, as mentioned, that I will be talking a lot about hardware, because this hardware is really hard, right? And this hard word you can repeat 10 times in a sentence if you're talking about electronics or if you're talking about IoT. So it is something said like that hardware is really hard, and that's why the people who have expertise in hardware, they are hard to replace. Fine. I don't know if you can understand this, can extract some meaning out of it. So if you have a good understanding about the hardware, about the semiconductor, then that knowledge keeps on adding, and it becomes difficult to replace a person in a company who has a good understanding of the hardware, because it takes a lot of time and efforts to get that expertise, right? So this is something contrasting to the software, and the knowledge about hardware is not easily available everywhere, right? So that's why I'm basically talking about the difficult part, about the hard part. And this is also one of the reasons why we do not have too much of products developed in India. So most of the startups, most of the companies, they prefer to work on the software, entire system, whether it is academic or industry. Entire system is shifting towards the software, because maybe that is something easy to learn, or maybe a lot of resources are available. But hardware is really hard. If you are making a product using some hardware, so you will be facing a lot of challenges. Okay, so sensor, if you just recall a couple of slides back, the diagram which I've shown you, so we have the sensors at one end of your IoT system, and selecting the right set of sensors is really important. And there are various parameters which you must consider while you are selecting proper sensors. Cost is obviously one of the parameters, may not be always important if you are more concerned about the quality. But yes, supplier is very important, particularly if you're talking about semiconductors and the current market situation with the China, which is going on. So getting supplies of the electronics might be a challenge. So from where you are getting it, who is the supplier, what quality they are providing, how genuine is your product. So this is a very important part you must think about. So same component is available for 10 rupees and from one seller, and maybe for 100 rupees from other seller. And there are a lot of differences. So it could be the second or third copy original. Now, what is the accuracy and precision? I'll show you some examples about this part, that what kind of accuracies are there. So you must very clearly identify or find out that whatever component you are going to use, so what level of accuracy you want and what level of accuracy is available with a particular model of a component. So how quickly it is available, large quantities. So this is very important, mainly for the semiconductors. See, semiconductor industry is a game of volumes, right? And if I give you one example, anything that you purchase, once you are going for a product, making a product, and you need to have some component. Let us say it is, if one piece is available for 100 rupees, and if you can order for 1000 pieces of the same component, so it will not be 1 lakh rupees, you might get it at only 40 or 50,000. So this is the volume game in semiconductor industry, and that is why companies like China and Taiwan are leading, because they play in volumes. So they make one thing in large volumes, so their requirement for the semiconductor components is very huge for one component, and that's why they are able to reduce the cost. And this is where we are struggling. So we are making in small volumes. So any new product which is being developed, so somebody would like to make 50 pieces or maybe 100 pieces for pilot or for trial basis or for samples, and that really increases the cost of your final product. But if you are able to make 2,000 pieces, 5,000 pieces, and then the cost could be even 50% of the actual retail price. So the large quantities, whether they are available in what cost, at what cost they are available, and do you really need them in large quantity? So this is one very important factor for any kind of hardware selection. Then what is the range of the parameter you want to measure? Because sensors, they are measuring some physical parameters. So what is the range you want to measure? So that should be clearly known to you. And power consumption, very important. Most of the IoT devices are battery operated, right? So any power hungry component will reduce the reliability of your device or the life of your device. You may not be able to frequently change the battery. So power consumption is very, very important, and a reverse calculation is required. So it could be like what battery you are able to put and how much power it will be, or maybe depending upon your application, how much power you require. And then it's just like making a budget or a power profile is created. So you need to know the power profile of each and every component, how much it will consume in different conditions. So I'll give you some example about this part. Right, so this is how one basic component, temperature sensor. If you just have a look at the data which is given here, so there are different models. One very common which we use in the lab, a TI component, a very low cost, fine. But just look at another similar TI component, a slightly higher cost, and the one from SparkFun. So that almost huge cost difference. So $10 for one piece. And the difference is the one which you see from SparkFun, so that is an active sensor, whereas the other ones from TI, they are passive sensors. So I hope you are clear. So being the faculties, and I don't know about students, if you have some doubt, you can ask. But whenever you are using a passive sensor, so it will give you one particular value through multiple wires, and you then need to process that to get the actual data. Whereas the active sensors give you the real required parameter through a single wire. Right, and that's why their cost is very, very high. So, and the same thing is if I talk about Indian currency. So if you talk about maybe the temperature sensor or the moisture sensor, a lot of environment monitoring projects are being done. So humidity sensors, so simple component could be available like 50 rupees, 60 rupees, but when you go for the active sensor, so it could be somewhere around 1,500 or maybe 2,000 rupees. So that is the difference about the selection. So range could be different, sensitivity could be different, and what volume they are available, you have to check. So most of the components have a minimum order quantity, right? So if you want to purchase particularly SMD components or QFN packages, so nobody's going to give you 5 pieces or 10 pieces. So they come in rolls or maybe some bigger packages. So what level, how much quantity you require, and whether that quantity is available or not. So all these things you need to decide before you make a final selection about your components. Another example, light sensor. So there are various types. You can have a photodiode, phototransistor, or simply a photoresistor. So what is the accuracy? So it's not given for some types, whereas one phototransistor gives you some accuracy. Then what is the current? So variable 3 microampere, and then some in milliamperes. So what is the range of the light intensity that can be measured? So more or less similar. But yes, response time, a lot of variation. So 55 millisecond and 15 microseconds. So huge difference in case of the response time, in how much time you will be getting your result, right? And this time could be critical in case of power optimization. So if you want to trigger your device on and off for some part of time, then in how much time you will get the response, accordingly you have to supply power to your device, and accordingly the overall power consumption of your system will increase. Okay, so coming to the second part, after the sensors, actuators I'll not talk much about. Maybe you can see the actuators in some example which I'll be taking later. But yes, IoT development board. So this is one of the most important parts. So this is where your processor or your controller comes into the picture. And please note that we are talking about development boards, and they are also known as prototyping boards, but these are not the actual components which you are going to use. So there are many types of these development boards, and the name itself says that you can use them to develop your application, to do the prototyping, to test your circuits, or which components will be behaving how, the logic which you're going to implement through programming, what algos you have developed. So you can do a testing of that part only. but these development boards are not suitable for end product. And this is one of the common mistake that many people do. So they build the applications using development boards, and then they try to put the same board in the end product. So it's not going to work, right? So that's why when we talk about product development, it is generally said that your prototype is ultimately going to be a part of your scrap, fine? So you just have to throw it in a bin, and you should be ready to do that, or maybe reuse it for some other application. So your prototype is never going to be a part of your final product. Okay, and that is about the development board. So this is how they look like. Very popular Arduino. I think everybody must have seen the Arduino. Even the school kids are using these Arduinos nowadays. Even people who are not at all related to technology or technical domain, so they are also using these Arduino boards now, because so much of content is available and it's so easy to use. So different types of Arduinos, than Intel Galileo, a very common board. NetDuino is there. Raspberry Pi is there. So these are the actual development boards that you can clearly understand just by looking at them, that you cannot put these kind of boards in your final product, because there will be many other components connected to this board. And if you put this in your product, then it will become very bulky or may not be cost effective. So there are a lot of issues with these boards. Right, so just like sensors, so there are various parameters about selection of these boards, and this could be really critical. So cost could be one factor, and then what are the specifications? Uh, Important specification, very important, I'll say, because the way you're developing your logic or the programming which you are building for your application, that will require some particular computing capacities, right? And if you want to shift from prototype to end product, so you are not going to use this prototype board. You will be using standalone processor or controller, right? And that will look like something else. So this is how your controller is going to look like. So it could be an SMD, it could be a through hole, QFN package, right? So now, one thing about selecting a processor is you must be sure that the controller or the processor which your prototyping board has, the same controller should be available in the form of a standalone package, right? And what would be the changes when you implement the programming? So this is really important, because if you select a particular processor for prototyping, and then in your end product you feel that you are not able to take it to the sleep mode, or there is no low power mode, right? So then your end product is going to consume a lot of power. So you have to be very careful. So, and this is one of the major problems with Arduino, that it does not have, it uses Atmega 328 P, and it does not have any low power or sleep mode. So you cannot put it to sleep mode so that you save the energy. So it will keep on consuming your battery continuously, right? So you have to be very careful. And then how do you shift your code from this prototyping board to the actual final product? Do you need to rewrite your code entirely, or your end controller is compatible with your prototyping board? So these things are very important. So what are the IO pins available? So if you go to Arduino Mega, so it has large number of IO pins available, GPIOs available. But will your final controller, maybe 40 pin or so, have all those IOs available? So you have designed a system, you have say around 34 GPIOs in your prototype board. So you have connected all those hardwares. But when you convert it into a final product, so you find that your controller has only 15 GPIOs. So what do you do with the rest connections, right? So these could be really challenging things, and you have to think about such issues when you're selecting a particular prototyping board. So what kind of programming options are there? Then open designs, a lot of open codes applications are available. You can use those applications. Then supplier. So again, if I talk about Arduino, it is available for 200 rupees and it is available for 1500 rupees. And the difference is the originality, or what level of copy is there in the board. So most of the Arduinos that are generally available in the market, 300, 200 rupees, so they are second or third copy of the original board. So go to some website, online supplier, which give you a certified product, which give you a certification of originality, and you can see the difference. And obviously, it is not going to affect much because it is a prototype and ultimately going to be a scrap for you or reusable. But yes, accuracy will differ. Compatibility with sensors and actuators, how many analog and digital pins are there, what voltage and current levels you are having. So all these things you need to think about. Okay, so if I just take an example, I said that your prototyping board may not be actually used in your end product. So this is how your prototyping board will look like, right? So you have Arduinos and then you have all these relays. So this is a typical automation system project, very basic project which many people make, and it has a Bluetooth, so you can control it through a mobile phone. So this is how your prototyping circuit schematic will look like, but this is obviously not a professional look. So particularly for the students, I'll suggest, and the faculties who must be guiding a lot of students at different levels for the projects, please make sure that these kind of schematics are not there in the reports, because if that report goes to any industry person, or if the students show it to any company at the time of interview, so people will understand that you are far from what is being done in the industry. So because when you convert it into a product, the things will look something like this. So this is a better way. So maybe, but still it is not exactly a product. So for this system, if you want to make a schematic for your board layout, so this will look something like this. Whereas when you convert it into a product, so the entire thing will change, and a more professional PCB or schematic would look something like this, right? So this is a more professional, something, an approach which is being followed in industry. So it's just like programming. So if you write a program, so in most of the IT companies, so what they do, they just ask the student to write a piece of code. So they are not testing the programming abilities, but what they are testing is how much professionally the student has learned. So the way you write your code, the way you do the indenting, the way you are writing the comments in your code, so that clearly shows that whether you have learned it just for the sake of academics, or you have really worked on some professional projects, or you have done some internship with good company, or you have done internship from some XYZ training institute, right? So that shows. And similarly, in case of hardware, the way you are making your schematics, which is there in your reports, or how you draw it, so that will clearly show that whether you have some understanding about the products, how the industry works, what standards are followed by the industry. So these will differ. So it is almost similar product, but entirely a different way of representing. And further, if you go to more advanced stage, when you're making a PCB, so this is how your PCB will look like, right? So it is not having your prototyping board, it is having a controller. So whether we are able to make this kind of PCB or not, and this itself is a big market. So people who are able to develop multi-layer PCBs, multi-layer board design, if somebody has a good understanding, good knowledge, so there are a lot of opportunities in the market to do that. Even they can take a job of it, or they can even do a freelancing, because this is required. Every hardware needs a PCB. So who's going to design it? And people are charging huge money just to design a PCB. So they say that I don't care whether you need 5 pieces or you need 500 pieces, but this is my minimum design cost. I'll be charging 5,000 rupees just to make this one design. And then how many copies you want, that is a different issue. So designing multi-layer boards itself is a big task and a difficult thing to do, right? And this is how a professional PCB should look like. If we are able to make these kind of designs in the reports, or if student shows that, okay, see, this is what I've developed. So that will clearly show that, okay, the person has learned in a professional way or has some experience, right? So this is a simple prototype, what we do in the lab or what we show in case of projects when they are submitted, but nobody's going to use it like a product. So when you are going for a product, so there will be huge changes. And I think Arduino Mega is being used. It's not written here, but from the shape, it looks like this is Arduino Mega. So that is big in size, right? So this is a prototype, or we can say a lab project, but I'll suggest that do a bit of refining. Even the projects should not be submitted in this stage. This is a very raw form. Some better form could be like this, though it will involve a bit of cost, right? A bit optimized. The controller has changed. This controller is used ESP32 or maybe Node MCU in some of the products, but still it is not the recommended one. By if you talk about big industry standards, so even this is not recommended because it consumes a lot of power and depends upon the application mainly. right? But this is a more professional way of representing that what you are making. So if this fab facility is available, so the projects should have these kind of systems. And this is more professional way. So you don't have your controller or your prototype board on base, IC base, but things are there. So you can see a lot of SMD components. And this is the product type. I can understand this cannot be done at the institute level, at the college level, in the labs. But yes, the students must know that when they are going to make a product, so this is something which they will be working at. So, and this is purely a volume game. So these kind of products cannot be made in small quantity. It will be very costly because many of these components are available only in bulk, right? But if you just look at the transition, that this is something, a prototype. I'll not even call it a prototype. So this could be, I guess, a proof of concept or very initial stage, right? And this could be a prototype, fine. And maybe for pilot projects, this could be quite useful. And this is the actual finished product, right? So this is how the hardware transitions from initial stage, lab stage, to a final product stage. And there are so many challenges. Now, if your controller is not available in this kind of package, so then the life would be very difficult. You may have to redesign your entire circuit. You may have to do entire programming again because the pin configuration will change, component values will change, the power levels will change. So there are many challenges. So that's why I say that just have an idea in your mind that what you are going to make finally, and who is going to use it, what would be the requirements of your customers. And that's what we talk about, talk with the startups when we say that any product startup is there. So you have to make a final product. So you should have a clear understanding that what kind of things you are going to sell in the market and in what form they will be accepted in the market, right? So this is about the basic introduction of the hardware. I'll come to one particular controller now, the prototyping, the Arduino Uno, which is common. Most of you must have seen it, must have used it, but I will be talking about some hardware integration or some connections, that how do we really make it, okay? So there are some good things and some bad things about this Arduino. So I'm not a supporter of Arduino, definitely not. Talking about the product, but yes, for prototyping, it is good thing. A good thing, if I talk about first, is it is very clearly written over here that compatibility is there. A lot of IO ports are there. Most of the sensors, actuators can be connected. Many libraries, pre-built libraries are available. A lot of functions are available. A lot of open source content is there on internet. Even you don't need to go to the internet, just install the IDE of Arduino, and there are must be around 100 examples within that IDE, and you can just copy that and build your application. So that is the good thing about Arduino Uno. The bad thing, one is that you cannot put it to a sleep mode, power down mode. Another thing is the code which you build here is not exactly embedded C, right? So Arduino has its own development environment, and the file which it generates is .ino file, and you cannot take that INO file into any other controller. Fine. So, so this particular model is using Atmega 328P. Fine. Whereas if you just you develop your application, fine. So your code is uploaded in your controller. Now you say that I take this controller out and use it in my product. So it will not work because there is a lot of extra circuitry involved, and the code which you have compiled, so that requires your IDE environment to run. So this is one major challenge. What you can do is, there is a solution to it, and I don't know how many people know about it. So the solution is that your Arduino IDE has an option to generate hex file. Fine. And most of the controllers have a programmer with them so that you can directly upload a hex file into your controller. Okay. So this is one option, that you have built your application in Arduino. Fine. But obviously you cannot use this in final product. In final product, you will be using your standalone controller. So generate a hex file, put it in the same controller, and use that controller in your product. So this is one option. Because the file saved the .ino file in Arduino, so that is not of much use. Okay. So these are some of the good things and bad things about Arduino, and the industry never supports it, but this is the best option for prototyping. Oh, so many boards are there, right? So most common is the Arduino Uno R3, then Arduino Nano, which is very small in size. Mega is there if you need a lot of input-output ports, a lot of GPIOs, high computing. Then you can go to Arduino Mega, but it is very big in size, right? But the most common are Uno and Nano. Okay. There is one in the center, you can see in the image, one circular part. So this is also, I think it is Arduino Lily or something. It's not mentioned which name is there. But yes, these forms are also available. So there are so many types of boards available. Okay, and just have a detailed a study about the board which you are going to use, what is the requirement, and then you can select one of these boards. There are so many other prototyping boards, Raspberry Pi. Okay, so this is again very common. Now it is not simply a microcontroller, but it is called as a microcomputer, right? And that is mainly because of its strong capabilities. So it is built upon ARM Cortex processor, 1 GB RAM. This appears to be small in today's world when even your phones are having 8 GB or 16 GB. But yes, 3-4 years back, 1 GB RAM was good enough for microcomputing devices, right? And 1.2 gigahertz processor, right? So I used to work on 433 megahertz when I started working on computer. So, and your prototyping board has 1.2 gigahertz. It's fine. Good. Right. Then you have Bluetooth, Wi-Fi, everything is there. You can connect the cameras. So you have PiCam, special cameras, 40 GPIO pins. So 40, right? So many input-output devices you can connect. 4 USBs. Okay. So my laptop is not having 4 USBs. So a lot of connectivity options are there. And this Raspberry Pi, it's a very strong, very powerful computing device, but a bit difficult to use. You have to, generally Python is preferred. You can use many programming languages, but generally Python is preferred because of the kind of applications which are developed using Raspberry Pi. And ARM Cortex is very strong processor and used in many IoT applications. Intel Edison is there. Intel Galileo is another modified form of this. So not that powerful as Raspberry Pi, but yes, 500 megahertz, 1 GB RAM, Wi-Fi, Bluetooth 4. So that is Bluetooth Smart or BLE is there, and it has different forms compatible with Arduino and other miniature boards. Then particle photon, this is also very common, very popular. STM32 is being used here. So the next 2 days, we are going to have experts from this company, ST Microelectronics, and so they will be talking a lot about IoT application development. So they generally use STM32. And one information I would like to give here, that now even your Arduino, one latest version of Arduino is using STM32 controller, right? So latest, you can just search on the net. I don't remember the name. Maybe they might tell you tomorrow, or you can ask them. So there is one recent version of Arduino which is using STM32. And the advantage is that STM32 is available in almost all packages that you require. Fine. So particle photon uses the same controller and not that fast in processing, but yes, you can build many applications, and there are different models available of this. So Nucleo is another very popular board which uses STM32, advanced version of STM32. So you can search for the Nucleo. It is called as STM Nucleo. Okay, now and this is also very common. A lot of students are using it in the projects, ESP8266. So that is mainly for Wi-Fi connectivity. So we cannot exactly call it as a prototyping board because the controller available here is not very powerful. So this is one model EX which has a Tensilica MCU, 32-bit MCU. But the main thing is that it has a Wi-Fi on board, right? It's very small in size and it has Wi-Fi and 16 GPIOs. Flash memory is there. Main use is any controller which you are using. If you are using Arduino Uno, it does not have Wi-Fi. You want to provide Wi-Fi connectivity. So just attach this small ESP8266 module, right? And then you can provide the Wi-Fi connectivity to your Arduino Uno or any other board. Node MCU, this is again very popular. It has reduced its popularity slightly with when this ESP32 came into picture. But yes, still again, it is very small in size and it has Wi-Fi, onboard Wi-Fi. That is a big advantage of using it. So it is based on ESP8266. Limitation is mainly the power, the computing capacity. It's not that good for the Node MCU compared to other similar devices. But yes, it is quite popular and a good alternative to Arduino Uno. Looks more professional if you put it on a board, takes very small space. So you can have a more professional PCB using Node MCU. The more preferred one is ESP32. Most of the products these days which require Wi-Fi are using ESP32, right? So if you want to look something better than Arduino, go for ESP32, and it is compatible with your Arduino IDE, right? So all the benefits of Arduino programming are available when you are using ESP32. So there is a bit of process that you have to follow. The tutorials are available online, that how do you add the libraries of ESP32 in your Arduino IDE, and then you can use it. Fine. So this is very good because it has Bluetooth on board, it has Wi-Fi on board, so a lot of peripherals are there. SPI, I2C, all communication protocols are there. And some of the models you can see, the more common one is DevKit V1, right? So this is a very popular one, V1 version. Most of the people are using it. But then ESP32 thing, that is another SparkFun. So, and just you can get it from the market. It's not very costly, maybe around 300 or 400 rupees, the local ones. But it is very popular these days. And you can put it to sleep mode. The power consumption is a bit lower in this case. So that is another advantage here. So you have an ultra low power processor, coprocessor, whereas Arduino is not having that. Okay, so this is about some options that you have for the prototyping board. And now coming back to the Arduino board, because I want to go into some kind of hands-on taking you into that part. So these are various, right, so now the name is written, it is LilyPad. So the circular one, I've not seen it physically till date, nobody has used it, but it is available online. So Arduino Uno, Mega, Nano. Mini is not much used, but Nano is more used. Right, so these are the commonly used Arduino boards. Coming to the main board, Arduino Uno, the most commonly used one. So it has all these things: power inputs, USB connectivity, a lot of digital input ports for bit PWM. Then serial programming, you can connect a serial interface. Then controller, I've told you, at Mega 328 is there. Then you have some power supply sections, 3.3 volt, 5 volt, and then a lot of some analog inputs are there. Right? So giving the power input and taking the power out of the Arduino. So this is very important. So there are two options available. Either you can use connector using some adapter, AC to DC adapter, or some other battery connector, and you can give a supply to the lower part. This black connector you can see. So this is where you can give a supply to a battery or adapter. Otherwise, you can directly power it from any USB port of your laptop or computer. Fine. So it requires quite less power. So but one major thing is that do not give both the supplies. So that might damage your Arduino. So some people sometimes try that I'll give more input, so I'll be getting more output, but it does not work like that. So you should connect one of these. Either you should connect your power connector, or you should connect a USB, and it works from that part. And then you have a reset switch over there. Right, so it has for the output, you have 5 volt pin, you have 3.3 volt pin, and 3 grounds, 2 on the lower side, analog side, and 1 on the upper digital side. So you can extract the power out of it, any 5 volt or 3 volt device, sensor or actuator, you can power up using your Arduino output, but you have to be careful about the current which is available, right? You should not draw extra current from this, your board will get damaged. Okay, a 9 volt battery is good enough if you want to give it an external supply. Right, so these are the pins, the GPIOs, general purpose IO pins. So you have the digital pins on upper side and analog pins on the lower side, and all these pins can be configured to be input or output. So there are programming commands through which you can configure. You have to configure that whether you are going to use the pin as input pin or output pin. A lot of devices can be connected to them. Okay, and your analog pins, if you're not using these analog pins, you require more digital pins. So you can always use the analog pins for digital operation, because 0 and 1 it can understand, but digital pin will not be able to understand the analog signal. Okay, so these are some of the basic commands. So how do you define that whether your pin is being used as input or output? So pin mode is the syntax, and then you have to give the pin number. Or a more professional way is that you give a variable name to your pin number and then just use that variable name here. So that will make the code more understandable. So you just use it just like you are using temperature sensor, you're using a motor, you're using some moisture sensor, right? So define your pin accordingly. That okay, temp sense equal to 9. So that means pin number 9 is being used to connect your temperature sensor. And then when you use in the code pin mode temp sense input, so that means your temperature sensor is being used as an input device. Okay, so then you can send an output. So digital write is the mode when you're giving output to the device to a particular pin, and you can set it as 0 or 1, any particular pin. So if you have connected such as any sensor to your digital pin and you want to switch it on or off, you can just send a low or high signal to your pin. So low is 0 and high is 5 volt. Similarly, you want to read the data from the digital pin. So you have digital read command. So just give the pin number. So whatever is there, so that will be taken into your controller. Then how you want to use it, you can store it in some variable or you can put it on display or on the serial monitor, whatever you want. Similarly, for the analog pin, so you have analog read and analog write, right? So analog read, so when you want to take the data in from your analog pin, and when you want to send the data out from your analog pin, so that is analog write. You have to give the pin number or the variable name and the value which you want to send, right? And one interesting thing is that when you're reading an analog pin, so it is going to be a 0 to 1023, right? So whatever the sensor is doing doesn't matter. So it will give you convert that minimum and maximum value in a range of 0 to 1023, and then you have to do some mathematical operations to convert it or to maybe calibrate those values to get the actual form in which you require it, right? And then there are some ADC pins mapped to 6 channels. So 10-bit ADC is there on Arduino. So this is how you can convert your analog data into digital data, right? So this is one more feature available here. So they are the PWM or pulse width modulation. So very much used in many applications. So you can see that there are some pins which have a special symbol with them, and these are the PWM pins. And these pins you can even use for the transmission of data, your TX and RX. Just give me a minute. Right, so these are the pulse width modulation pins. So what they do is, they can be kept on and off for a different duration of time. So that is basic concept of the communication, pulse width modulation. So 0 is that will be continuously off, and 255 means will be continuously on. And in between, a value will decide that for how much duration the pin will be on and off. Right, so speed control generally is done with the help of PWM. So this is how one simple program can be written. So we have given a sensor value. A0 is the analog pin 0. We have given it a name, sense pin, and defined it as an integer. So it is used for some, let us say, as LDR we are connected. And then you have there are two major sections in the code of Arduino. I'll show you the interface also. So you have a setup section, and then you have the main code section. So setup is where you do the initial some setup commands, configuration commands, and in the loop section you write the major program body. Okay, and just this is how you can use it. So int sensor value, you can give some value here, and then analog read, just read that value, and then you can print it. Serial.print ln is line. Every value will be printed in the next line. If you use simple serial.print, so all the values will be printed in same line, just like one word. And print ln means it will go to the next line. So this is how we can, the way, the structure, how the code is written in Arduino. So it's very easy to write. Okay, so let me take you to some examples. This is one wiring diagram, so you can connect another thing. Okay, Wi-Fi is connected here. So CC 3300. This is a Wi-Fi board, just like ESP8266. So this is how you can connect your board, and then you can do the programming. So the pin configuration is given here. You can just see that part. Let me take you to one application. I'll just stop the screen share and share another one. Let me run my Arduino. Since we are not in the lab and everybody may not be having the Arduino and all the hardware, so I will be telling you about some of the simulation tools. So they are the actual Arduino IDE environments, and you can build your application and you can even simulate your application. So maybe we can try those things right now online. Okay, so share new screen. So are there any queries? If you have some inputs, or if you want to discuss something? So a lot of faculties are there. You
Yes,
must
sir,
have
yes,
worked a
sir.
lot on Arduinos.
Yes, sir. There are some questions which I have asked in the chat box.
Where is my Arduino? Okay.
It is from Dr. Abhishek Sharma.
Fine. So
Amit
when
sir,
you install
am I
this, just
audible?
from the Google, you can search for
Am I
Arduino
audible,
IDE,
sir?
you download it and install it. So this is how it looks like. I think one program is open here. Let me just close it. Okay, I'll open a new file. Right. So that was the standard Arduino, and I've just created a new file. This is how it looks like. So you have the standard structure here, setup. You just do a setup, and before setup, you can even define your variables or whatever things that you are using or some other functions. And then this is the loop part where you have to write your commands, right? And now when you are connecting your computer, obviously when you are programming your Arduino, so you will be connecting it to your laptop or desktop through the USB port, right? And so what you have to do is you have to select a particular board. So go to the tools part. Under tools part, you can see the board option. Fine. And in this board option, you will see that there are so many types of boards available which are compatible. Right now, you don't see ESP here. So I've not added ESP in this system. But you can just check the tutorials. These are available. So you have to download a separate library of ESP. And once you download and install that library, it is done right from here. Within the Arduino IDE, you can do that. Right. And then along in this board option, you will see ESP32 also. And similarly, there are many other boards which are compatible. Even Node MCU is unofficially compatible with Arduino. So you add the library and you will be seeing multiple options. So just as you have so many Arduino Uno boards, similarly, you will be having so many ESP32 boards also. So you have to select your proper board if you're using Arduino Uno, or maybe you're using some other. Just give me a second. I'm getting a call.
Sir, am I audible? Amit sir? Amit sir, am I audible? Amit sir, first you have to unmute yourself.
Yeah, I've done that.
Yes, sir. Sir, am I audible?
Yes.
Yes, sir. Sir, there are few questions in the chat box.
Okay, actually, just now I checked. There was some problem with my speaker. One of the wire was not connected. I'm using a
Yes, sir.
headphone, so that's why I thought that I'm not getting any queries.
Yes, yes, sir. Yes, sir. No,
Okay.
no issue, sir.
Right. Yeah.
Sir, may I announce it?
Yes.
Yes, sir. Sir, there is a question from Dr. Ashish Sharma that what is the difference between double IoT and IoT?
Okay, fine. So double IoT is industrial IoT. So when you are building an IoT application for some industrial automation purpose, so that is generally called as IIoT. So it is mainly industrial IoT. So it's as simple as that.
And second question is from Ven Kuni, that whenever you want to send data from Arduino to your computer, which one is better between serial and parallel communication?
We are using serial communication with the Arduino. So there are two major ways. One is the SPI and other one is the UART. That is the TX and RX pin. Fine. And directly, if you want to see, I think you are able to see the screen. So I'll just show you right here. So once your Arduino board is connected to your computer and you have opened this IDE. So in this case, there is a serial monitor. If you can see on the top right corner of the screen where my pointer is there. So you have a serial monitor. So you just click on the serial monitor. Okay, so right now the board is not connected. So this will open a new small window, right? And whenever you are using a serial.print command in your program, so whatever output is being generated through your analog or digital pin, so that will appear on the serial monitor. Right, so generally SPI is used or TX RX pin or UART way is used with the Arduino. So if you want to look into the environment IDE through the serial monitor and serial print command, you can see. Otherwise, if there is any other interface which is connected like Bluetooth or something, so they have generally TX RX pins or the UART pins, and through them we send the data. Some of the interfaces work on SPI, which is a bit complex to connect. It requires multiple pins, but most of them work from TX RX. Yeah. Any other?
So, other question is from Rishabh Kumar. He is asking to say the name of Arduino programming IDE once again. He is requesting.
There is no specific name, just it is called as Arduino IDE. So just type on Google Arduino IDE. So it will take you to the website of Arduino and you can download it from there. It is available free of cost. And after you install it, so the window which is there on my screen, it will look like this.
Okay. And the other one is from Amrit Muskan. She is asking any online simulation for ESP8266?
ESP, I'll show you, not exactly simulation for the programming part. There is one option available. I'll show you, but for Arduino, entire simulation can be done. So there are, I'm talking about the free software. There are many paid tools available like Proteus, or there are many EDA tools where you can build your embedded applications. But for the free versions, generally Arduino is supported.
Okay, thank you, sir. That's all they have asked till now.
The participants, maybe you can unmute and ask the questions if there are some more.
Okay.
I'm very sorry for that. I was not aware that my speaker is not working.
No issues, sir. No issues. Okay, if anyone is having the question, please ask one by one.
Hello, sir.
Yes.
So I have a question that before even the term IoT was defined, then we all know that Zigbee and other devices like Bluetooth, even Bluetooth was present there. But then what was the purpose of giving the term IoT? What is the difference from then and before?
Right. So that's why I said that before this IoT term was coined, we were more commonly using the term cyber physical systems. Right. So it is just the way industry moves, or people keep on giving new terms when something becomes more popular. But otherwise, cyber physical systems is a very old concept. And it started when you were able to connect your devices through internet. Right. So it's just a terminology that some company comes with the new technology just to promote their products or their services, and that hits in the market, it becomes popular. So IoT was just a term given by a few people, Internet of Things, that you have a lot of things and everything will be connected to internet. So let's call it IoT. Just as I said that Cisco has given one term, IoE, Internet of Everything, right? But it's not that popular, but IoT is more popular. So it's just a term coming up in the market. Otherwise, we used to have cyber physical systems. You will find books 15 years old on cyber physical systems, right? And one difference that we have now, if we can say that the cloud computing is a part of it, and two-way communication is something which is expected in case of IoT, where the devices directly can interact, exchange data between themselves without any human intervention. So this is one added feature of IoT. Yeah. Anything else? Any other question?
So the next question is from Giriza Shankar Mishra. He is asking that please explain the different types of sensors.
Oh, there are hundreds of sensors. If you are online, maybe if you can be a bit more specific. Almost every physical parameter, there is a sensor available. It is just a transducer. So types of sensors, you can say analog or digital. Generally, we say that we have passive sensors and active sensors. So passive is what is giving you a raw data, you have to process it. And active sensor is, there is one single wire and it directly gives you the required parameter. Otherwise, there are hundreds of types of sensors.
And the other question is from Hassan. How was IoT before its fourth revolution?
See, fourth revolution, there was no IoT because fourth revolution, that's what I said, that it was called as cyber physical system earlier. So fourth industrial revolution is not only about IoT, but yes, IoT is one part of it. Before that, it was called as CPS. So this is just a term and not a new technology.
Okay, anyone else? Sir, there is one more question from Francois. Has there ever been a system that allows to transfer charge between two devices?
Yes, definitely. There are wireless charging devices and there is wireless power transmission also being tested. So I think that's what you want. Franco, sir, are you there? If you can specify a bit more.
Hello, sir.
Yes.
Sir, first of all, thank you for this amazing session. The question that I'm trying to ask here is that, like, let's say I have my own mobile phone with me, and then a friend has their mobile phone, and we are not like having electricity where we are, and like that friend's phone is off. So, is there any system, or has there ever been a system like that that could allow me to transfer charge from my mobile phone to my friend's mobile phone?
Yes, there are systems, there are mobile phones, but it will depend upon your device. There are devices which talk about wireless power transmission, and many of the phones have this capability. Right now, the main thing is that you need to have an energy harvesting. So in terms of technology, we call it as energy harvesting. Right. So that means solar is one of the very common thing. So you are extracting the energy from the solar, you are converting it into electrical energy, and then you are charging a device. So this is one way, but the new technologies which are being explored in this case is like extracting your energy from RF, which is there in the environment. So there are so much of radio frequency devices being used, and there are so many radio frequency signals in the ambience. So devices are being developed which can capture those RF signals, which basically are electromagnetic signals, and extract the electrical energy out of those RF signals, and then use it to charge your batteries. Right. So these things are being developed, and the domain is called as energy harvesting, a very popular domain. A lot of researchers are working in this area. You can explore energy harvesting, but yes, every device will not be capable of doing it. You need to connect the external device with your phone if your phone is not compatible with the wireless charging. So you'll have to look for, there are devices available, but not that effective, which can extract the energy from the environment and do the charging of your battery.
All right,
So
sir. Thanks a lot. Do you also think that that could actually be applied to like electric cars nowadays? Because most of the times, like in the US and in some European countries, so we now have these electric cars, right? So like, let's say there are two different cars or two different electric cars in a traffic, and then the other one is also off. Do you think the same system can be applied to like electric cars, so that an electric car which is in a traffic could transfer charge into like another electric car which is also in the same traffic?
Yes, definitely it is possible. But then, as I said, there are two points which I will make here. EVs, battery charging is a challenge for EVs. One thing is that you need to transmit So first thing is you need to have a secure system where one vehicle which is providing the power will be transmitting the energy, and then it will be in an encoded signal, and then another one which which wants to receive that energy, wants to be charged, so that has to pair up with the transmitting device, and then the transfer of energy will take place. So the problem is that how do you make it guided, because it is wireless, so it will spread in the environment, and spread the moment it spreads, it will lose its energy, and then how much energy you can extract, because a lot of power is required. So that is one issue. So right now it is being tested for small things like very small batteries where you require maybe 3 volts or 5 volts. So those kind of things it is being tested. And there are even, if I talk about cellular devices, I'd say mobile devices. So technology is being tested in case of mobile devices where the signal which you are getting from your BTS, your tower station, so the same signal can provide energy to charge your mobile device, right? So, but right now these technologies at a very low power. So for vehicles, you need a lot of power. And the main thing is that how do you do the pairing? Just like Bluetooth, you have a pairing. Some kind of pairing mechanism needs to be developed between two vehicles. But it is possible, but not yet developed right now. It's a good area to work on. So again, that's like energy harvesting. But in this case, you have to transmit and then you have to receive it. And there should be pairing between two devices. So that is an issue.
Thank you, sir.
I can see another question from Seetal.
Yes, sir. She has asked that IoT is making every devices and appliances connected. So how we will overcome the safety and privacy challenges of it?
Okay, fine. So if you go to the IoT network, most of the protocols that are being used nowadays are quite secure. Not all of them, but yes, technologies like Zigbee or the communication protocol basically which you are using, that should be secure enough. Fine. Otherwise, it's a big issue. Security is a very big issue. And the most challenging part in this entire system is the edge devices. So when you go from your sensor node to your cloud, so there is an intermediate device which is known as edge device. So that is the most vulnerable part because you have minimum security at that level, right? So again, it's a matter of research. So security at edge devices is still under research, and there are a lot of issues. The countries which have deployed IoTs, so we have seen cases where the system was hacked and the garage was opened remotely and the car was stolen. So these things have happened, and security is the issue. So there are systems with 128-bit inbuilt security, like if you go to 6LoWPAN or LoRa systems, so they do have inbuilt 128-bit encryption. So that provides a lot of security, but still it is not 100% secure. It is an issue, open issue, and you can work on this as a research area. I think there was one more question between by Wakenj, if I'm right. The question is, accuracy is one of the performance parameters. Is there a universal reference to compute it for a particular sensor? So every sensor has its own parameters in terms of the accuracy, just like you have the accuracy for a resistance. So there is a tolerance value. Similarly, for every physical parameter, so there is a tolerance value given by the sensor. So you have to go to the data sheet of a particular device and read from the data sheet that what kind of accuracy it is giving you. That's why I said that once you are selecting a particular hardware, so you must know the exact model which you are going to purchase, go to the data sheet of that component and see the critical parameters, just study them. And then only it will be decided that whether you will be getting the required performance or not. Okay, any other question?
Anyone else? I think, sir.
Okay, fine. So I'll give you an idea about the interfaces before we move on. I think we have around 10 minutes left for this session. And this one I'll not be able to extend because 11:30 I have to join another meeting with a client. So let me quickly stop this. IDE, you are clear that you install it. Then one thing is that you have to select a board. Once you connect your Arduino to your computer through USB, so you have to select a board from here, the right board, Arduino Uno, Mega, Nano, whatever, or maybe ESP. And then you have, once you select your board, this port option will become active. So you have to see that the proper port is selected. Generally, automatically it detects, right? But sometimes it may not be available. So you have to select a proper port, and then serial monitor you can open from here also, or from this small button. And then a lot of sketches are available here. So this is the standard Arduino IDE. Coming to the online part, let me just share another screen. Where is my, okay. Right, I have to move this sharing window. Right. So I'm going to open a tab. Coming to the simulation part, so a lot of EDA tools are available, right? So CAD tools are available for embedded systems. Proteus is one very commonly used, but for different controllers, there are many more tools available. You can search on the internet. But what I can talk about, if it is for Arduino or ESP, so there was one system called circuits.io. So it was taken over by the company Autodesk. So now it is called as Tinkercad. But there is another one available with a similar name, Circuito.io. You just check the name, CIRCUTO.io. So this is one open platform, very good for making your schematics or making your hardware. I think there is one more question on chat. Right. So there is one question. We are having two different types of Arduino boards. How to know that this or that Arduino board can be used for a project? So this, the most important part is how many GPIOs you want, right? So Arduino Nano is having the less number of GPIOs. Arduino Uno, some intermediate, and Mega is having maximum number of GPIOs. So that is one of the major factors. And then the controller which is being used. So it will purely depend upon the requirement of the application that you are going to make, that what computing power you require, how many GPIOs interfaces you require. Accordingly, it will be selected. Okay. Fine. So this is the environment. You can create an account over here. And if you just go to the app, click here. Okay, so this kind of, you might get some initial warnings because I've been using it earlier, so I don't get any warnings, but you might be getting some basic instructions initially. You just click OK to them, or maybe next, and then you will come up with this interface. So this is one interface where you can build your circuit and you can develop the code. You can get entire information about the actual hardware, what is the cost, what are the specifications. You can prepare the board layout. So there are a lot of things that you can do here, right? But one limitation is that you cannot run your code here. So it is not a complete simulator. It can only help you in designing your code. And good thing is that if I just, you can see the options here. You have controllers. So various types of controllers are available. So you have Raspberry Pi, you have Arduino Uno, and let's see if ESP is there or not. Yes, ESP32 is there. Node MCU is also there. Atmega 328 standalone controller is there. Okay, so many controllers are available. You can pick any particular controller. By default, it is Arduino. You can just replace it. And the moment I connect any particular input, let us say I take this sensor, right? I don't know how to use this sensor, how many pins it is having, which pin is to be connected where. The good thing about this interface is that the moment you pick it, you click it, it will give you all the information about this particular sensor, right? And you can add it in your library, in your design. You can directly go for purchasing. It connects you to the online purchase platforms, markets. I'll add it in my circuit and it is connected. Right, so this is really wonderful thing about this particular interface, that the moment you add any component into your this workspace, it automatically makes all the connections, and whatever additional component is required, breadboard is there, one interface is there, so it automatically connects everything. Let me take a connectivity module. Okay. Unselect the inputs and unselect the controller. I'll select only the connectivity. So what I have here, ESP8266 is there. HC05, let us take HC05. Okay, I click it, add it. Fine. So just Okay, so at my HC05, that is a Bluetooth connectivity module. It is already there in the circuit, right? So this is the good thing. The moment you add any component, it will automatically be added, and you can change them. You can change them wherever you want. Okay, you can edit them. You can change their colors. And if you go to the code section, this is the design section. If you go to the code section, automatically it is writing some piece of code for you, right? So basic connectivity codes, it is already writing using embedded C. And another limitation is that the code is very lengthy. It uses the basic Scratch programming. So it's very lengthy. You can edit this code, and whatever functions you want to add, you can implement your functions, your inbuilt function, user-defined functions, you can add in this section, right? So it is giving you all the firmware. You can download the entire list of entire hardware from here. You can download the code, and once you get all the hardware, then you can just download this code, take it to your Arduino IDE, and then you can test this particular code, right? So entire documentation you can prepare here, right? So this is one common interface. If you just want to make the connections and generate the code automatically, and then use it in your Arduino IDE. So this is one option, but the problem is that you cannot test your code. You cannot simulate or run your code in this particular part, right? So there is another interface when you go to the testing or running that code. Something else is there in the chat? Okay, no, just general message. Right, so I think I'll stop here for this particular session. We are almost 11:30. Or what I can do, maybe I can tell you about another one. Just try to explore some of the components here. If you get some idea, I'll take you to a couple of slides before I go to the next interface. Introduction to what we are going to do next. So there will be another interface on which we will be running the applications. So I'll take you through some examples. So basically, Bluetooth and GSM. So these two, I'll take you through the entire details of Bluetooth and GSM. Coding is not a problem in Arduino because a lot of online resources are available. It's more about how do you connect the hardware, how do you configure your hardware. So that is the more important part. Once you know that how your hardware is initially configured, after that, you can easily code it. Okay, where is my slide? Close one part. Missing. Fine. So this is what I'm going to talk about in the next session post lunch. How do we connect the Bluetooth and GSM hardware? How do you configure it? What are the initial settings you have to make? And after that, coding examples, I'll show you a bit of code and then you can try. But before going into this part, I will show you another interface where you can actually simulate your code, and quick couple of examples we'll do, and then we'll come to this part. So this is the Bluetooth. So there are various types of Bluetooth modules available. Two major types, simple Bluetooth, that is HC05, and the more commonly used now is BLE, Bluetooth low energy. And HM10 is one example, 8009 is one more commonly used. The chip, the IC which is being used for Bluetooth connectivity, so that is EGBT 045 is for HC05, and CC2541, this is for the BLE modules. Right, so these ICs remain the same. The rest is the other circuitry and the connectivities that you get. So these kind of components you will get. So this first one is the standard XC05, the upper side, and this is the back side of XC05. So you have all the pins labeled here. So what you have to connect, basically VCC, ground, TX, RX, and enable. This is what you connect here. This is the BLE chip, one BLE module, and the lower one is another BLE module, BLE09. And so you should know that how to connect it and what kind of configuration is required. Right, so I'll stop here for this session, and we'll come back post lunch. Spend almost half an hour on simulation environment, and then I'll show you the configuration of Bluetooth and GPRS. Wi-Fi I'll not touch today because the next 2 days with ST Microelectronics, that will be core on IoT and their Wi-Fi is required. So possibly they will be telling you about Wi-Fi connectivity on STM boards. But let's see if we get time. So maybe I can give you a brief about Wi-Fi also. Right. So any couple of questions before we close for this session?
Sir, there is one question from Kuni, Vern Kuni, that like we are having different types of Arduino boards. How to know that this or that Arduino board it has to be used for your project?
So I think this I've already answered. Fine. So it purely depends upon your application, how many GPIs you require, what computing power you require. So accordingly, it will be decided.
Thank you so much, sir, for your valuable and informative talk. We will join you after the lunch.
Sure. I hope I've added some information because these are very basic things, and people talk a lot about these things. So I don't know if I've really given some inputs to it or not. But
no, sir, it's really very informative, and first of all, it's theoretical and as well as the job oriented course you have given us, the enlightened us with the all the new trends and new concepts. This is very I'm actually very grateful to you.
thank you very much. Fine. So see you post lunch.
Okay,
Thank you.
Thank you so much. So FDP participant may leave the meeting, and the FDP will resume at 1:30 p.m. And Sharda students can remain in this link. We will continue after the 10 minutes. Again, I repeat that FDP participants may leave the meeting, and this FDP will resume at 1:30 p.m. VAC students can remain in this link. We will continue after 10 minutes. So Sharda student, don't go anywhere. Remain in this link. We will start in just 5 or 10 minutes. Thank you for the patience.
Hello, ma'am.
Yes.
Ma'am,
Yes.
can we leave? अभी कुछ
You're
session
not
होने?
supposed- You're not supposed to leave. Now it will continue. Okay. May I know you're a student of Sharda?
Yes, ma'am.
Yes, yes. Danish, wait. Now the VAC program value-added courses will continue. I would like to invite Professor Ashish Gupta, sir, HOD of Electrical and Electronics Engineering Department, to give a talk on design advances for wireless sensing application. Welcome, sir.
Okay. Good afternoon. Good morning, everyone. And today, in this particular value-added course, we will be discussing upon the various design requirements whenever we are designing any circuit for wireless sensing applications. So to begin with the introduction part, we all know that wireless sensor networks vary greatly in applications and distributions. Now, since this is the third day of our value-added course, and you have seen that in wide variety of applications, we are using these sensors. So depending upon their application and distribution, we require that the network that we are designing should be having longer device lifetime. The size of the device should be small and it should have less cost. So whenever we are designing any circuit, we have to keep these three parameters in mind, that it's cost effective in terms of size and in terms of its lifetime. Also, the another requirement is that for operating these devices, low power is very essential because the sensors are inaccessible and battery replacement often requires disassembling the infrastructure. So once if our network is consuming more power, it means that every time there will be a need for replacing the battery, and this replacement of battery is a more cumbersome job because it requires disassembling of the infrastructure. Tiny sensor nodes are needed for many applications to collect and communicate environmental data without interfering with the subject under study. Also, low sensor cost is vital for the mass deployment of ubiquitous sensors and for creating large wireless sensor networks. So obviously, whenever we are designing any large sensor network, then it requires deployment of different types of sensors on large scale. So our sensor cost should be is a vital parameter in the development of that particular network. Today, wireless sensors are composed of multiple components on a printed circuit board. So whenever if you have seen any type of sensor, then generally these sensors are composed of various components which are implemented or connected on a simple printed circuit board. Bulky batteries are included in the system to power the circuit components with adequate lifetimes. Now, for the meeting the power requirement for various components which are used in the incorporation of a particular wireless sensor network, so many batteries are required which make our circuit more bulky. So, new circuit design advances are creating exciting opportunities to dramatically reduce the size cost of future wireless sensor networks without affecting the device lifetime. So the main opportunity for the persons who are involved in the design of these wireless sensor networks is to how we can reduce the size of the network and how we can reduce the cost of these networks. And one thing we have to keep in mind, that is the lifetime or the device lifetime is not affected. So in this process, what we do is first of all, we try to scale the transistor. Now transistors which we are using can be bipolar transistors or CMOS transistors. So scaling is one parameter which can help us in achieving less cost, smaller size, and longer lifetime. Sensor and packaging technologies will enable unprecedented integration and decrease size, power, and cost. So these are the parameters which can help us in integration of wide number of components, and also it helps in decreasing the size, power, and the overall cost of the network. Robust low power circuit design will enable the use of smaller, less expensive power sources while still increasing the device lifetime to reduce maintenance cost for battery replacement or recharging. So we have to look up for the procedure how we can replace the battery, or we have rechargeable batteries where we can continuously keep the consumption of power to a minimum. Also, in transmission methods, we require smaller antennas that consume less power. So new wireless transmission methods will be required which have less power and small antennas. So as a result of all these changes, we will be having a millimetric scale wireless sensor network that will be suitable for multitude of applications. So if we keep in mind all these things, then by applying these things or these technologies, we will be having a wireless sensor network of millimetric scale, and it can be used for a wide variety of applications. For example, if we look at this particular figure, which consists of different sections or the components which are used for implementing a particular sensor network. So we have power source, then these power sources are connected to devices which can manage the power. Then we have microprocessors, controllers, sensors in front end, then memory of the system, then the means for communicating, that is wireless communication through antennas, and sensors, MEMS sensors, that is micro electrical mechanical sensors. Now, the sensors can perform multitude functions, including collecting of data, then processing of that data, storing and transmitting this particular data using limited power supply. So our network that we are designing should be capable of performing these functions, that is collection of data. Once the data is collected, then we have to process that data. After processing, we have to store that data, and that stored data has to be transmitted wherever it is required. And all these operations, all these functions have to be carried out with limited power supply, because we have to keep a check on the amount of power consumed by the system. Now, this particular example represents an IOP system, which is intraocular pressure, which is a technique for measuring the pressures of eye pressure measurement. Then we see here the first and the foremost part that is required in this design of a complete wireless sensor network is the sensors and the front end. So individually, we will be discussing about each of these different blocks which are used in miniaturization of a wireless sensor networks, that is the sensors and front end, then the memory part, the microprocessor part, the power management part, the controller part, and the communication part. So starting with the first part, that is the sensors and front end. Wireless sensors are capable of monitoring different environmental conditions such as light, for which we have light sensors, temperature sensors, pressure sensors, vibration sensors, or electricity sensors. The output that we obtain from these sensors may be either in the form of a voltage or a current. For example, we have a photodiode which generates a voltage and current which are related to the intensity of the light. That is, depending upon the magnitude of light intensity, the output generated by this photodiode will be a voltage signal or a current signal. And the amplitude of the voltage or the current signal will be directly proportional to the intensity of the light. Another example of a sensor which we generally use is a capacitive or piezoresistive sensors, which output a voltage based on the pressure-induced deflection of a microelectrical mechanical system diaphragm. So depending upon the magnitude of pressure that is being sensed by our system, we can use these capacitive or piezoresistive diaphragms. In a typical sensor front end, as shown in figure 2, the raw sensor output is amplified to magnify the alternating current components and supply adequate drive strength for subsequent circuits. Now, generally what happens whenever we find out or we calculate the output of a sensor which is in the form of a voltage or a current signal, generally the magnitude of this, the amplitude of the output signal is very less. So we have to amplify that particular output to certain calculative level. So therefore, we require the amplification section. So this is our simple representation where we have cascaded large number of sensors, including image sensor, temperature sensor, MEMS sensors, and the output of these are passed through low noise amplifiers. Then we have these output will be voltage or current, and the voltage and the output current signal will be in the form of a analog signal. So we require a device which is analog to digital converter to convert this output voltage or current to digital signal, and then digital signals can be easily processed. So the data are then digitized with the help of an analog to digital converter, and then it is digitally processed, stored, and transmitted. It is vital that the low noise amplifier and ADC introduces minimal noise while operating on a tight power budget. So we have to keep two things in mind, that once we are amplifying the signal, then our objective is that the noise signals which are present in the output of the sensors are not amplified and then being rejected by the amplifier circuit. And also we have to keep in mind that the power is also less consumed. Now we discuss in detail about these sensors which we are using, starting with the temperature sensors. Temperature sensors commonly digitize a voltage based on the temperature sensitive nature of parasitic PNP bipolar devices in a CMOS process. So basically we have temperature sensitive bipolar transistors which are incorporated with CMOS processes. That is, we have bi-CMOS process, and then these temperature sensors can generate an output voltage which can be digitized. Then the base to emitter voltage of a PNP device with fixed current is complementary to absolute temperature. That is, instead of calculating the absolute temperature, we take the differential voltage that exists between the base to emitter of a PNP device, and then that voltage is calculated on the basis of the temperature sensed by the temperature sensor. Also, the difference in VBE between two PNP devices with different sizes or currents is proportional to absolute temperature. Now, suppose we are using a differential pair, then in that case, the difference between the base emitter voltages of the two devices having different sizes or different currents, base currents, then that difference will be proportional to the absolute temperature, which will be measured by the sensor. Either of these voltages or some combination of the two can be fed into an analog to digital converter to produce a digital representation of the temperature. So either the differential voltage or the individual voltage or the combination of both can be applied to analog to digital converter to produce a digital representation for the temperature. And we know that the biasing voltage for PNP is typically greater than, the bias current is greater than 250 nanoampere. So to ensure accurate current ratio between devices and ADCs, commonly we require microwatts of power for sampling frequencies in the range of kilohertz. So this is the basic requirement which you have to keep in mind whenever we are designing a particular circuit. Then the second in this is your image sensors, which are used for basically military surveillance, gastrointestinal scans, and automobile traffic monitoring. So these are the basic applications where we generally use image sensors. And normally, when we are implementing these image sensors, we use CMOS technology. So CMOS image sensors are easily integrated with, and these CMOS devices can be easily integrated with digital circuits to allow for a small form factor. A traditional CMOS image sensor consists of an array of photovoltaic diodes. So normally CMOS image sensors are nothing but a combination of photovoltaic diodes arranged either in series or in parallel combination or mixed combination of series and parallel combination. Now, when exposed to light, the electron-hole pairs are generated in the diode's depletion region. This is the working of these image sensors. So when light is exposed to them, then in the depletion region of the diode, electron-hole pairs are generated, which are swept out of the depletion region through diffusion, therefore creating a photovoltaic current which is related to the intensity of light. So it means that if the intensity of light is less, then less number of carriers will be moving out of the depletion region, and hence the magnitude of photovoltaic current will be less. So directly we can say that the photovoltaic current which is generated in these photovoltaic diodes will be directly proportional to the intensity of light. This photovoltaic voltage is commonly driven onto a column shared bit line digitized with an ADC and processed to determine the original light intensity. So this voltage is applied to a bit line which convert it into either a 1 or 0, and depending upon the magnitude of that, we can find out the magnitude of the light intensity. For more robust low voltage operation, pulse width modulation based image sensors are used that drive a pulse onto the bit line instead of a voltage. Now this is the typical circuitry of a pulse width modulated image sensor which generates a bit line structure. So what we have is we have a buffer, then we have MOS transistors, comparators, and the counter which counts the magnitude of the bit line. So each pixel in the image sensor array contains a photovoltaic diode, a comparator, and a read buffer. The reverse biased photodiode is pre-charged to a set voltage and then exposed to light, causing the photocurrent to lower the voltage on the capacitor. So these are the steps which is the operation of an image sensor, that is your pulse width modulated based image sensors. So every pixel of the image sensor array, it consists of a photovoltaic diode, then a comparator, and a read buffer. First of all, we pre-charge the reverse bias photodiode to a certain value. That is, sometimes it is up to 0.3 or 0.5 volt. And then it is exposed to light. And once the light is passed through it, then the carriers start moving from the depletion region and causing photo current to lower the voltage on the capacitor. This voltage is compared with the ramp signal to generate a pulse with duration from the beginning of the ramp until the ramp voltage equals the photodiode voltage. So as you know that the function of comparator is to compare two input signals. So one will be the reference signal, another will be the signal which we have obtained from this photodiode. So if you look at this figure, then we have shown here the comparison between two inputs. One is your ramp of value 0 and one is your photodiode value of 0. Another set we are taking ramp of magnitude 1 and photodiode of magnitude 1. Now once the value of this is compared, that is, if the difference voltage is becoming 0, then the output will be low, and if the difference voltage is high, then the output will be high. So depending upon because the value of ramp will be always constant, and the magnitude of photodiode voltage will be depending upon the intensity of light, and the intensity of light may cause this photodiode voltage to be high or low, and accordingly the comparator will generate a high output and low output, which will be driving this buffer. And once this buffer is derived, it will either generate a read signal or write signal, and accordingly the bit line will be activated. The resulting pulse is driven onto the bit line with a read buffer composing of two N-channel MOSFETs controlled by a read world line. One counter per bit line is enabled for the duration of the pulse, and the counter value represents the photodiode current. So once the counter increases, it means that the current has passed through the photodiode. During each cycle, one pixel on each bit line is read, and by sequentially firing all of the read-write lines, the entire array is measured and an image is recorded. This is the process how we can use this image sensor to capture a particular image. That is, for each pixel, a particular bit line is being read, and then by firing sequentially all the right lines, the complete pixels are rearranged and we obtain the final image. The most commonly used digital analog to time to digital technique can be voltage scaled to 0.45 volt with suitable robustness and signal to noise ratio. The low power time-based scheme is more suited for the peak and average power requirements of a millimetric scale system. So this is the requirement, that is the power should be less, and the time-based scheme is most suited for finding out the peak value and the average value of the power for which is required for a millimetric scale system. The third component in the wireless sensor network is your amplifiers, and we all know that the function of an amplifier is to increase the magnitude of signal. So amplification is needed to provide gain for suitable signals which are low swing output from the sensors and provide adequate drive strength for subsequent circuits. For example, a microvolt signals which are picked up by neural probes are too small for ADCs to digitize. That is, the once we are monitoring the neural, that is the activities performed by the brain, then generally the neural sensors that we use generate output voltages which are in the range of microvolts, and the magnitude of these voltage signals is so small that we cannot use these signals to obtain digital output by using analog to digital converters. So therefore there is a need for amplifying these microvolt signal so that they can be easily digitized by using analog to digital converters. Also, noise sources such as thermal and flicker noises from resistors or devices can easily mask the intended signal. So generally, if the magnitude of the output signal which is generated by a sensor is equivalent to the magnitude of the noise source or the noise voltage which is generated from the other components used in this network, then the original signal will be masked and the properties we cannot study. So for this reason, the first stage of the sensor node front end after the sensor itself is a low noise amplifier. So the function of this low noise amplifier will be to remove the noise component so that we are left with only the intended signal which we want to study. This low noise amplifier is designed to amplify the signal while maintaining a high signal to noise ratio. Many sensors such as temperature, humidity, and certain medical sensors have low frequency outputs, so also their bandwidth is small. However, these applications have strict offset and signal to noise requirements. So these are some of the features which we have to keep in mind whenever we are working with these sensors. So at the time of designing these amplifiers, if we are having a circuit which contains the output from some sensors which are measuring temperature, humidity, or medical sensors, generally the output frequency is very small. And once the output frequency is small, so their bandwidth is also very small. So we have to keep a strict offset between the bandwidth and the signal to noise ratio requirements. Also, low noise amplifiers with vastly different requirements are also used in RF receivers to amplify signals picked up by the receiver antenna for chip-to-chip or chip-to-base station communication. So we have to keep in mind that whenever we are designing these low noise amplifiers, so we have to also keep in mind the mode of communication that we are using for the transmission of these information, and either we are using chip-to-chip communication or chip-to-base station communication. Although amplifiers are typically designed with devices in strong inversion or weak inversion, but normally these provides a higher gain to DC current power ratio. However, bandwidth and signal to noise ratio are degraded. So whenever we are designing for higher gain or DC power ratio, these amplifiers, then there is a compromise between the bandwidth and the signal to noise ratio, because if we are designing for high gain or higher current DC power ratio, then the bandwidth and signal to noise ratio are degraded. So following discussion provides a general first order analysis of these effects. Now, as we all have studied, that gain is the product of transconductance and load resistance. So if the load is an active device and all the devices are switched from strong to weak inversion, the value of transconductance decreases with the square root of drain current, and the output resistance or the load resistance varies inversely with the drain current. So if you see here the effect of these factors, one parameter, the transconductance, is decreased with the square root of drain current, and R naught increases almost inversely with the drain current. So in combined effect is that gain is not categorically degraded. Bandwidth scales with the reciprocal of the product of resistance and capacitance at the node, causing the dominant pole. So once the value of R increases and C remains constant, so bandwidth also decreases. Thermal noise increases with R, decreasing signal to noise ratio. The noise floor for weakly inverted devices does not depend as heavily on DC bias current, allowing for further power saving. So this part that we have discussed can be mathematically expressed in this by using these equations. We have seen that gain is directly proportional to GM times R naught, and GM is proportional to the square root of the drain current, whereas the load resistance R naught is directly proportional to the inverse of the, inversely proportional to drain current. So overall, the gain will be inversely proportional to square root of the drain current. Similarly, if we look at the bandwidth is directly proportional to the RC product of the value of resistance and capacitances that are used in the circuit, and resistance is again proportional to the inversely proportional to inversely proportional to drain current. Therefore, we see that the overall effect is that bandwidth is directly proportional to the drain current. Similarly, if we talk of thermal noise, so thermal noise is directly proportional to 4K TR, where K is the Boltzmann constant, T is temperature, absolute temperature. So these two are constant. So the thermal noise is again found to be inversely proportional to the drain current. So if we look at these all three equations and we try to find out the effect of drain current on the three parameters, that is namely the gain, bandwidth, and thermal noise. So there is three different relationships which we have obtained for the three parameters. That is, gain is inversely proportional to square root of the drain current, bandwidth is directly proportional to drain current, and thermal noise is inversely proportional to drain current. So obviously if drain current is increasing, then it will cause the bandwidth to increase and gain and thermal noise to decrease. Similarly, if drain current is decreasing, then it will cause the thermal noise and gain to increase, but bandwidth will decrease. Then the next component that we use in this wireless sensor networks is your analog to digital converters. After amplification, the data from analog sensors are converted to a digital value so that they can be processed, stored, and transmitted. So once the process of amplification is converted, the next step is to convert that analog signal into a digital output. And for that purpose, we require the analog to digital converters. Once the signal is converted into its digital form, we can easily process it, store it, and transmit it for further processing. The most commonly used analog to digital converter is your successive approximation register, ADC, which is being widely used, and it performs a binary search of the voltage range to find the input voltage. So basically, in successive approximation register, the process that we use to convert an analog signal to digital signal is by method of binary search. A digital to analog converter is used to create the analog representation of the digital value stored in the registers. Now again, if we want that particular signal which we have stored to convert it into its analog counterpart, then we require digital to analog converter, which converts the analog digital version or digital signal to analog signal. This is compared with the input voltage, and the register is adjusted accordingly based on whether the input voltage is higher or lower than the register value. So once we have obtained the value of the signal and we compare it with the value that is stored in the register, and we can decide whether it is more or less than the registered value. Another type of A to D converters we generally use are dual integrating slope and pulse position modulation analog digital converters, which convert the analog input values to a time and then create a digital output with a time to digital converters. These mostly digital techniques are more robust for low voltage operation than analog techniques, providing another opportunity for even lower figure of merit. The power of the ADC is directly related to the ADC sampling frequency. That is, the amount of power consumed by analog to digital converter is related to the sampling frequency, that is the frequency of the sampled signal. So if we are going for uniform sampling, then it requires a sampling rate of 8 times the frequency of interest. And in case of non-uniform sampling technique, the oversampling rate can be reduced to 1.7 times by using a post-processor to reconstruct an analog signal with the same maximum frequency of interest. The technique used with a pulse position modulation analog to digital converter can achieve to an almost a figure of merit of 98 femtojoule per conversion step. That is, at each step when we are converting an analog signal to digital signal, then we are achieving a figure of merit of up to 98 femtojoules. The time to digital converters used in this ADC topologies can be implemented by starting a counter when the capacitor is charged and recording the counter value when it is discharged. So this is the process that we use in time to digital converters. Another part that we observe in the block diagram of a sensor network is the processor. Sensors have the ability to gather large amount of data about their surrounding environment. However, not all of these data contain useful information. That is, once we have designed a system using sensors, then it can sense the information from the surrounding. But we does not need all these data. That is, it is not helpful to us. For example, sensors monitoring stresses in bridges only need to report when faults are found. That is, only we have to find out that condition when faults are developed in the bridge, and not the information that is being sensed by the sensor during the complete usage of that particular bridge. Transmitting raw sensor data wirelessly requires a great deal of energy, since active radios are generally power hungry compared to other sensor node circuitry. So when we are transmitting any raw data over our network, then it requires more amount of energy. Therefore, again, what we require is that only needful information should be transmitted, so that less amount of energy is being consumed by the transmitting medium. Moreover, frequent wireless traffic leads to data congestion sensor networks, and it increases the data latency. So if you observe that we are transmitting the complete information without segregating the actual information that is needed, then over the network which we are transmitting the information, then there is possibility that data congestion may occur in that particular network, and that increases the possibility of data latency. So to avoid these effects, many wireless sensor networks nodes perform digital signal processing to extract and compress useful sensor data with a microprocessor before transmitting that data. So mainly there is importance of digital signal processing and microprocessing unit for transmitting the data. So in this we use the VDD scaling is the most effective way of reducing processing power, and in some cases we can achieve even a saving of 2 picojoule per instruction that is being transmitted over the network. Voltage scaling has a strong effect on energy consumption since the dynamic switching energy of the microprocessor scales quadratically with the VDD. That is the power supply which we are using. Voltage scaling also increases latency, especially when VDD is scaled below the device threshold, that is the threshold voltage VTS to the sub-threshold region. Now, another important component which we generally use in a wireless sensor network is the memory size. So generally we require information to be stored. So we require the memory size to be in more, and generally the most commonly used memories are your CMOS compatible memories that includes static RAM and dynamic RAM. So static RAM, in case of static RAM, we can use voltage scaling that reduces the dynamic energy consumption in memories, and low voltage static RAM is prone to functional failures because process variations leads to destructive read operation and insufficient write margin. So these are some of the basic static RAM cells which we use: 6 transistor, 8 transistor, 10 transistor, and depending upon the amount of energy consumed by or the power dissipated by each, we can decide which particular part we are going to use for memory section. Now, while 8 transistor and 10 transistor SRAM have higher robustness than differential 6 transistor SRAM cell, at low voltage they are considerably larger because of increased device count. Actually, the size also matter, because if their power consumption is less and they are occupying more area, then again they are not of our requirement. The increased bit cell area can limit memory size in sensor nodes that require a small form factor. Embedded DRAM, another type of memory structure that we use is your embedded DRAM, which is fully compatible with CMOS logic and only requires 2 or 3 devices per bit, substantially increasing memory density. Its excess power is high, thus it is more suitable for long-term storage of data, which is accessed infrequently. That is, we can store data in that particular in embedded DRAM for a longer duration of time, and also we can store that data which is not required by us. In addition to increased density, embedded DRAM can achieve higher read and write margin than differential 6 transistors SRAM cell, and also it has lower leakage power due to reduced device count. And this is the basic structure of a simple embedded DRAM cell where we require only 3 transistors as compared to 6 transistor SRAM cell, and it functions more effectively as compared to the previous counterpart. Another is the part of wireless communication. Wireless communication is a critical function for any wireless sensor network, and it can be achieved using a variety of media, including light, sound, electric field, and RF electromagnetic field. Now, among these mediums, that is transmitting data through light, sound, electric field, or RF magnetic field, the RF communication is a prominent approach for wireless sensor networks. The RF transceiver can easily dominate the power budget of a wireless sensor network. Even the most energy efficient transceivers based on standards like Zigbee, Bluetooth, and Wi-Fi, which consumes tens of milliwatt of power today, which is well in excess of the power budget of a typical wireless sensor network. That is, nowadays, the wireless sensor network, which are generally implemented, they use few microwatts of power. And these systems which we are using for receiving, that is Zigbee, Bluetooth, they consume milliwatts of power. The power consumption of wireless transceiver must be reduced both at the circuit level by developing more energy efficient RF circuit and at the system level by using RF communication more judiciously. So therefore, our objective is whenever we are designing any transceiver system for wireless communication using RF medium, then we have to design it in such a manner that it consumes less power at system level and as well as at circuit level. So we will be discussing the two techniques for, that is the techniques which we follow for reducing the power at circuit level and at system level. So this is a typical diagram of a transmitter, and this is the typical diagram of a receiver. So when we are designing any this, so we have to keep a check on all in circuit technique. So if you see here that in case of a transmitter, we have a data encoder, a frequency generator, a modulator, and a power amplifier. So in circuit technique, we will be trying to minimize the power consumption of each of the individual block that is being used in the implementation of a transmitter part. Similarly, in case of receiver, where we have a filter, a low noise amplifier, a frequency generator, a demodulator, and data decoder. So again, to minimize the circuit, to minimize the power at circuit level, we have to minimize the power requirement of each of these individual blocks. So the technique which we generally use at circuit level is the weak inversion operation of the building blocks used for the RF transmission. And it has been known that analog circuit or analog signals consume more power as compared to digital signals. Therefore, low voltage operation has become to receive attention from researchers as well. So now what we can do is we have to devise a technique where we can use low voltages for the operation of our RF devices. However, due to low bandwidth, weak inversion, and low voltage design, it is not suitable for us to use components which require high frequency operation. So therefore, the use of high quality RF MEMS passive components also holds a promising path in the power reduction. Another method is we can use bulk acoustic wave resonators to achieve excellent filtering in receivers. And we can also use ultra wideband transceivers which send narrow pulses of energy to transmit data, and they have a number of attributes that are well suited to low power operation. So these are the basic features which we can obtain by using ultra wideband transmitters in our system. So, but this system, ultra wideband system suffers from disadvantage that the noise affects the frequency spectrum of these signals. So the final technique that we use is the back scattering radio architecture, which provides a significant contribution in terms of power constraint, radio frequency, tags, and mostly this technique is used in RFID tags. Then in system technique, we have, while the energy efficiency of circuit components will play an important role in reducing the power overhead of RF communication, system level techniques play perhaps a more important role in determining energy efficiency. So one of the simplest solution is that we shorten the transmission distance. That is, the transmitter and receiver must be at shorter distance, and the exact distance for calculating can be found by using the Frisch transmission equation, which relates the power and the distance between the transmitter and the receiver. If we wish to go for longer communication distances, we generally use multi-hop communication. So the energy, this is so. Similarly, we can reduce the power significantly by minimizing the amount of data sent over the RF link. An onboard microprocessor can analyze data locally to determine which pieces of data should be sent off chip, and also compress data packets for further reduce the burden on the transceiver. With microprocessor, power consumption as low as several hundred nanowatts is obtained, and local data processing is far more energy efficient than RF transmission. So to conclude, what we have seen is that if we want to create a miniature wireless sensor network with long lifetime, the system architecture and all circuit components must be completely reconsidered for ultra low power operation. Recently, low power circuits and system design advances, along with techniques in development, have made the device for new applications which are possible, such as IOP sensing. And IOP sensing is a representative of emerging volume constraint sensing application with aggressive power budget, asymmetric communication requirement, and low duty cycles. The combination of these factors bring both challenges and opportunities to circuit and system designer. Now, there is a great opportunity for all who are interested in going in this field, that the main requirement is that we have to design circuits which consumes less power, occupy less area, and which consume less power and have longer lifetime. Okay, thank you.
Thank you so much, sir.
Any queries from the student side? Students, if you have any queries, kindly ask. Thank you very much, sir, for your valuable and informative session. Thank you, sir.
Okay, now FDP will resume at 1:30 p.m.
Dear students,
Ma'am, class is
everyone
over.
join sharp at 1:30 p.m. for the value-added courses.
Okay.
Thank you. You will get the attendance only after attending your value-added courses from morning 10 to 4 p.m. Any time the attendance will be taken, so kindly make sure you're attending the full time. चल अब microprocessor
Very good afternoon to all of you. So once again, I would like to take the opportunity to welcome Dr. Amit Sehgal sir to enlighten us with his knowledge. So,
Okay.
Amit sir.
Yes, thank you.
Okay, sir.
So shall we start or wait for a minute or two?
So just wait for 5 minutes to participate to get joined.
Okay, fine. So maybe in the
After
meantime,
that, we will start.
Yeah, those who have joined, I wanted to share one simulator, one online simulator. Maybe they can create an account online if they want to do parallel hands-on.
Participant will graduate.
Amit sir, you may start the session. Participate will gradually join you.
Fine, fine. Okay. So initially, I'll take you through some of the simulation. I'm just sharing my screen. Maybe those who are interested, they can do it parallel if they are online. If they have access to their computer. On mobile phone, it might be a little bit difficult, though it will work. So one tool I've shown earlier, one app, online system, that is circuito.io. So this system, you can design your circuits, you can get the code, though the code is very long and you have to make a lot of additions into that code. You have to reduce the size of the code and you cannot simulate into that particular platform. The alternate option that we have is very common system, which is used not only for the circuit simulation, but also for all kind of entire 3D system design. So if you are making a product and you have to make the circuits and there will be some outer covering, some body of that particular product. So both the things you can do over there. So you can just have a look. It's very popular and many people are using it these days, even at the initial school level. So tinkercad.com, if you just type those who are on laptop or desktop, or just maybe you can try if you can get a proper interface on your mobile phone, though it has a mobile app also. So if you just open the tinkercad.com, you will get this kind of interface. So initially it appears to be a 3D modeling tool. It was like that only. And the initial version was circuits.io, which I told you earlier that this was circuits.io by the Autodesk, and then it was shifted into this another platform having more of the 3D modeling content. So this is what it looks like. So this has the option to create a group. You can create a class into this, and then the students can join that particular class, and collaborative building can be done over here. Otherwise, you can just create individual login also. So you have to go to the join now, and from here you can create a personal account. Fine. So for group level, it can be educators and students can join a class. Otherwise, individually you can just create a personal account, or you can directly sign in through the Google account also. So since I already have an account over there, I'll directly go to the sign in. Fine. So I've signed in. I already created an account. So those who are online, they can try. They can just quickly create an account, and maybe some of the things they can do in parallel. Though I will not be typing the entire code, I will be using some pre-built models, but you can always try it along with. Okay. So once you log in into your account, so you will be getting this kind of layout where my username is there. I can add a photograph and gallery. A lot of modules, already developed modules. People keep on developing the models and share it, and that is available in the gallery. So it has its own blog, and a lot of online content is there. Learning content is available. Now coming to the development parts, there are three major sections for the development. The first one is the 3D designing, which you see right now. It is selected. So various types of 3D modelings you can do here, and it can even give you a file which can be taken directly to the 3D printing. So this is the 3D design. So all kind of shapes, characters, alphabets, even some standard structures are there. For machine parts are there, robotics structures are there, skeletons are there. So various types of options are there. Many tools are there when you go to a create new design. But that's not what we are going to do today. So we will be working on the other part, that is the circuits. So when you go to the circuits, and whatever you keep on building or developing here, or you add any other project which is there in the gallery, you open it and you can add it to your account. So it will be displayed in your account, just like it is being displayed right now in my account, right? So this is for the circuits where you can make your circuits, code them, and even test them and simulate them. And then code blocks is another recently added feature. So this is more like building blocks. The game which is used by the kids, small blocks you can use. So that is the code blocks. So we will be talking about the circuits. So you can see, okay, fine. So when you, if you have created an account and if you have logged in into this, so you just have to go to the create new circuit, since you will not be having initially any project into your account, or maybe you can go to the gallery. Right. Now, the good things and bad things about, again, just like any other tool, this also has. So one thing is that for this Tinkercad, you do not need to make any kind of installation or configuration. This entirely runs online. Fine. So whatever you do is running online. Entire designing and storage is online. Simulation, everything is done online. So you don't need too many resources on computer. But the other thing is that you need to be connected online. You should have internet connectivity. So if you don't have internet connectivity, you cannot use most of the parts. You cannot use only the earlier ones you can see. Even if you have a design ready with you to simulate it, you need to have internet connectivity. Otherwise, you will not be able to simulate. So this is more of a cloud-based system, right? So once you go to a new design, so this is what you see here. I'm not getting a complete interface, maybe because of the online call is going on. Let me just see. Okay, I'm not getting all the interfaces, but anyways, you generally see a grid over here. Right. So this is where you see various components on the right side. So basic components are displayed and you can select all. So all the components, electronic components, electrical components, they are available here. You can just pick them and place. So most of the sensors are available here. Input sensor devices, output devices, displays, motors, keypads, batteries. So even breadboards are there to make your circuit. And then these are the processor controllers. So Arduino R3 is there. Microbit is something which they have recently added. Microbit, still not used it, right? Atini is another chip. Then instruments are there, power supplies are there, meters are there, even oscilloscope, right? So many ICs are there. So it's a long list of components. So you just explore if you this, and you will be able to use many of these components to build various types of circuits, right? And then there are some standard categories, like if you go to Arduino, so this will give you some sample circuits, different circuits with very small components, one or two. So these you can use and just try. Right. Similarly, microbit is there. Some other circuit assemblies, basic assemblies are there for information purpose. So all you have to do is just select a particular component, drag it and place it here on your board. So whatever you want to use, you can just drag and place it. Let me take an Arduino. Right. So in this way, you can keep on adding the components here, and you can zoom it. Right. And from the right button, left button, you can even move it anywhere, wherever you want, increase or decrease the size. To make the connections, I'm not using a mouse, so it is a bit difficult to handle. With a mouse, it would be more easier. To make the connections, just go to a particular pin. It will tell you name of the pin or what function that pin has. So you just click one pin, and then wherever you want to connect, just click on that pin. Or if you want, you can even navigate to give a proper direction. Like I go from here, I click here, then I move straight, again click, then I change direction, again click, then again change direction, again I click, I can change direction and come here. Fine, and you can adjust. So this kind of routing or navigation you can do with the various components, so that the tracks are shown properly. So this is a simple way by which you can place the components on your workplace, work area, add various sensors or actuators, make the connections, and then when you simulate it, this USB will automatically be connected and your Arduino will be powered up, and then you can do all kind of simulations. For the coding part, when you click on this code button, right, so you get this window. So there are three different options in the code. So initial one, which you see, is a very graphical kind of thing. So if you don't know the programming, anybody who is not aware of the programming but has a basic understanding of the logic building, ESP8266, there is one question. No, this is not available in you can say Tinkercad. ESP8266 is not available. Only Arduino is available, and Microbit is one new which they have added. Right? So ESP8266 is not available. Actually, that has an onboard Wi-Fi. In fact, earlier it was having maybe around 4 or 5 months back, this was having most of the components, but then there were various security issues because this is all online. And once you configure it and you connect some devices, so the network which you are using for online, that becomes accessible to anyone who uses it, right? So there were some security issues. That's why they have removed all the Wi-Fi cards or any board which has an onboard Wi-Fi. So that's why ESP is not available now, mainly because of the Wi-Fi security issue. Right. So if somebody is not aware of the programming, what kind of syntax is to be used, so you can straight away use this graphical interface. So you have the input commands, you have the output commands, you have the math functions, you have all the control operations. So you can just pick and place them. This standard code automatically appears. So you can just select it and put it in the bin you're not going to use. And then you can start defining your inputs or outputs or your variables, whatever you want to use. So this is one block level approach, but if you want to know about programming, which is obviously required, so second option is that you can go to block plus text. Now, when you go to this particular section, in this case, you will be able to use the variables here, like graphical section you can use here, whatever way you want, you can use. And simultaneously, the code will automatically be generated. So this is one easy way to learn the programming of Arduino. You just keep on building your, this is just like a flow chart. You keep on building your flow chart here or algorithm in the graphical mode, and it will automatically build the code over there. But you cannot edit the code. I'm not able to make changes to the code. Right, so this is the block plus text. So you build using blocks, and simultaneously you can see what are the commands. So that will help you to learn that how I'm using the input and outputs, how I'm defining behavior of a pin, reading the data from the pin, sending data to the pin, or making some math operations. If I just use a loop here, say while loop I have added here, so it has given me the structure of a while loop. So I can just I don't have a variable, so let me create a variable here. Create a variable, right? I'll just add a variable somewhere here. So it will automatically do what is to be done here. So in this way, the code will be generated here. Fine. So this is one approach. Now the third approach is the only text mode. So the moment I click to the text mode, the entire graphical will go away and this text portion will be activated. And then you can write your code just like normal Arduino or any word processor or editor. Right? So you just have to write your code yourself, and that is the text mode. Now, one thing you have to be very careful while using it, you can go from lower level to higher level. That means from block to text block and to completely block text. But you cannot go the reverse way. The moment you go reverse way, your code will automatically be removed. Fine. Just like I go to complete text mode. So it will tell me the moment I shift to the text mode, my entire blocks will be removed. I will not be having access to the block level diagram which I have created. Fine. So it will be only the text mode. So now I can edit this code. Fine. And now if I want to go back to the hybrid mode, so it will tell me that the moment I go back to hybrid mode, this code will be removed. So this is one thing which you have to take care of. So initially, if you're not comfortable with the programming, so it is better to go into the block plus text mode. So you can use the blocks to write your program or build your application, and simultaneously you can read the code and try to understand it. And once you are comfortable with the programming, then directly you can go to the text mode. Fine, but shifting between block and text, if you want to go back to the block mode, make sure that you copy it. So this entire code, whichever is generated, copy it or download it, and then you will be able to use it in your Arduino. Fine. So this is how you have to use this particular interface, and then you can simulate it. You can export it to different file formats, and it even gives you the components, the list of the components it can give you. Right. So whatever you are using, so you will get a list of the components. You can just download it, and then you can take it to the market and purchase those particular components. Fine. So this is another feature. Okay. You can create notes over there. Right. So this is a basic interface. Now I'll go to one particular example. I'll go back to the home page. You can always change the name of the circuit, whatever you are making. I think there is another query in the chat box. Okay, no, fine. So I'll take one very basic, simple example. Room automation is there. Let me take another simple one. Fine. Right. So if you have made any particular circuit or from the gallery, you just copy paste into your account. So you will get this type of message first time you do it. So then tinker it, it will be, editing will be enabled. Right. So what I've done here is one Arduino is there. Then I've used a motor. It's a servo motor. You have a servo motor, you have a DC motor, geared motor, different types of motors are there. So I've connected a servo motor to my Arduino, and then there is a switch. Fine. And then there is one knob. It is just rotating. Could be considered like a potentiometer or something. And if I just take you to the code, I'll go to the text mode, hybrid. Right. So what we have done is we have to add a particular library. We are using a servo motor. So we have a servo.h. This is what we have added. Now we have a sensor, one variable I've created, sense1. Then there is a temperature sensor that I've added. then another variable integer I have defined, and position. So all these variables I have defined. So this is because initially I created using graphical mode, right? And whatever I'm using in my graphical mode, automatically it gets added into the code. So if I just click on the variable part, so whatever I've defined, like I, position, sense one, temp sense. So all these variables I have used in my code, right? So then what it is doing in the setup mode, I've defined the pins. So pin 4 is being used as input, and pin A0 analog pin is being used as input. And then there is a servo.attach. This function I've called. So pin number 3. So this is the pin number 3 where servo is attached. And this is the location on the workspace where it is placed. And then in the position, what I've done in the main code. So initially position equal to 0. So this position is related to the position of your servo motor. Fine. So initially it will come to its home position. So we have to set the initial position of the motor. Then I have created a condition. So digital read 4 is the switch. So if the switch is 0, then it will read the analog pin, that potential, that knob, and then it will convert the value of this analog pin into 0 to 180 degree. So this is a map function I've used. So what map function is doing? So I told you in the morning that our analog pins, so whatever they read, it is a value in the range of 0 to 1024. Fine. Now I want to convert it into the rotations of a motor, so which will rotate from 0 to 180 degree. So what I've done is I've used a map function. So this map function will be changing this value coming from the analog pin into another value which is in the range of 0. So 0 will be 0 degree and 1023 will be 180 degree. So accordingly it will rotate, right? And now this position which is converted, I've given this to the servo motor. So servo dot write position.
ग्राफिक को कोडिंग बनाना यही है अच्छा इसमें ना कुछ प्रोग्राम भी
please mute yourself.
मुझे ग्राफ करना है
Okay. So whatever value we have obtained by using this map function, so this value we have given to the servo motor. So this will decide the position, right? And then there is a delay. Okay. So now let's see how it works. I'll start simulation. Right. The moment I click simulation, then the Arduino is powered up. USB is connected. Now, if I just rotate this knob, you can see the motor is rotating. Fine. I can change the switch. I change it to another position. I rotate the knob. The motor is not rotating. Fine. It seems to be a very simple thing, but if I give you an application, now let's take a security system. So you have a camera, right? And then you are at another place and you have some joystick kind of thing or some knob and you are rotating it, and there is a motor connected to your camera and you are able to change the direction of your camera from another place. Fine. So very simple application and such a simple code and very simple circuit. So you can connect some Wi-Fi or Bluetooth over there, and then you can make it remotely operable. So this is how this environment is being used. So you have an Arduino, you have all the connections. You have to read that how to use them, which pin is to be connected where, make the connections, then do the programming. If you know the programming, directly go to the text mode and write your code over there. And then you can test your environment in the simulation mode. Right? You can change the names of these things, but you cannot change the size. Now, this is one important thing. When you are working on the 3D design part of this Tinkercad, so many of the objects, you can change the shape and size of them. But the moment you use these electronic components, you cannot change the shape or size of them. Now, this is because all the components have been selected as per their actual size, right? So that there is an option to convert a footprint of it. So you can get a complete schematic, and then it will be giving you the actual size. So that when you are making the outer body, so you should know that what size I require to make the body of my final product or my model. Right? Otherwise, you design it in 3D and then you print it, and after that, when you place your electronic components into it, you will find that the space is not good enough. So that's why all the components that you add, they are automatically adjusted to the physical size which is available for those components, so that you can make a 3D model and fit these components into that model. Right. So this is one very basic example. I'll quickly go to another example of automation system. Which is a more interesting one. Okay, room automation I'll take. We already have it deployed in our campus in various rooms. I've seen that you have this room automation system. The moment you enter into the room, your lights and fans, they get operated. Fine. So this is another thing. Some more components have been used here. So I have an Arduino. I have a temperature sensor here. I have an LDR for the light. I have a PIR sensor. So this is a PIR sensor. Then some supplies are there. So these are the power supplies giving to the relays, and then some light and a motor representing a fan has been connected. So this is a complete room automation system. Fine. So I'll just go to the code. I have a text file of this code. I can send it to you if you want. I can share it later on.
Yes, sir. You should share it. Share it, sir.
Okay. Right now, I don't know how is it possible to sharing it here, the text file, or I'll get it emailed to others. Right. So this entire code I have in the text file. I'll get it shared. So what we are doing here is again the same thing. So in the setup section of this Arduino code, so we have defined that what all pins are being used: input pins and output pins. Right. So wherever we have connected, like your temperature sensor, your LDR, your PIR. So these are all the input pins, and the output pins are the ones which are going to your light and your fan or the motor. So these are the two output pins. And then serial dot begin. So this is the baud rate. Fine. So when we are talking about GSM, so there I'll tell you that baud rate and why is it important. So serial dot begin 9600 is the standard baud rate that we use for serial communication. So then define some variables. I'm just reading pin number 8. So what do we have at pin number 8? You can just zoom it and find out. So that's why I said that it is always better to give the names to the particular pins initially as variable and then use those names so that you can find out that which values you are reading into which variable. So basically we are reading this digital pin 8, then analog pin 5 would be from PIR sensor, analog A4 would be from your temperature sensor. Then you have to do a conversion of the value which is giving you 0 to 1023. So you have to convert it into a Celsius scale. I've converted. Then I've applied a logic for the PIR sensor. Fine. So this PIR sensor will be giving you 0 or 1. So whenever there is a movement, it will detect. It has a range. So you have to define a range. If I just click here, so you can see, so there is a range, X and Y, right? And initial position of a target. Right. So it detects whenever there is a movement in its coverage area. So it will give a signal which is captured through the read pin, and then an corresponding signal is generated to switch on the light. So what this system is doing, so it is just reading the temperature, it is reading the light. From the light, it is controlling this bulb. From the motion, it is controlling the bulb. From the temperature, it is controlling your fan. So that code we have written over here. So we have condition if X is for the PIR, so digital dot write. So pin number 5 and pin number 2. So both of them will be activated, light and fan, right? Otherwise, it checks for some particular temperature also. So now if temperature is below minimum value, then fan will not switch on, only light will switch on. And if temperature is above a preset value, then your fan will also switch on. So it should not happen that it is winters and somebody enters the room and your fan is switched on along with the bulb, right? But if it is exhaust fan, that should be turned on, right? And similarly, if it is daytime, so the movement should not, the temperature is fine, but it is daytime. So the fan should be switched on, but light should not be switched on. So all these conditions have been implemented here by using if-else statements. You can use a switch case also instead of if-else. I've used a if-else here, right? So various conditions I have taken, like in which condition the bulb will be on, in which condition the fan will be on, both of them will be on. Okay. So you just write this piece of code over here. You can even do it graphically, but it is always good to do it programmatically because you know which part you have written where. Testing the simulation. Let's see. I'll switch off the code. right? So supplies are on. Okay. Let me see. Now, okay, good thing. Why we are doing a simulation? Now, if you make a prototype of this, then how do you show the temperature variation? Fine. So you use either ice, you or some heat, you give it to it. Then you can use the temperature variation, and then you can show it. Similarly, for LDR, you have to cover it so that to make a feel of darkness or light, and then you can see that whether your code is working or not. Whereas in case of simulation, it gives you the option to change the value in runtime. So I just click on the temperature sensor. So right now it is set at a particular value. So I can decrease this value and I can increase this value, right? So it is just like a real-time system. That temperature is changing in a real-time system. Fine. So I'll click on the this. Just let me shift it. Where is my target? PIR sensor is activated. Okay, so this is the this small dot is the target. Fine. So my target is moving. Okay. The moment I enter the range of PIR, the light is switched on. Your fan is also on. Fine, the fan is on because the temperature is high. Okay, now let me just reduce the temperature. I'll reduce the temperature. Again, I go to PIR. I'm moving. The bulb is on, but fan is, if I don't know if you are able to see, but the motor is not rotating right now. But the bulb is switched on because temperature is low. Similarly, I can change the light conditions. So there is a threshold set. I cross this particular threshold. Again, PIR. Target is moving, but bulb is not switched on because there is enough light. LDR is detecting that there is sufficient light, right? I increase the temperature. Again, now fan is rotating, but light is not switched on. So this is a simple automation system. So now your code is running. So all you need to do is just take these components physically, put it on a board, get this programming shifted to your code or to your controller, and you can use it. Fine. So this is how you can test. Basically, you can test the connectivities, what connections are to be made, and then what will be the programming logic. You can test it. So this is the one advantage of simulation. But yes, since we are using Arduino, you cannot put it into an actual system. So one thing is that copy this code, put it in Arduino IDE, generate a hex file of it, and then this controller at Mega 328 is available. So copy, load that program into at Mega controller, and then you can make a single board, small board, just as I've shown in the morning. Right. So these are some of the examples. Where is motor connected on chat box is there. So motor is connected to this relay, right? So we are generating an output pin. So output pin is giving a message to the relay, which is a NC relay, NO, normally open relay. The moment it gets a signal from the controller, so the relay connection is closed, and your supply, this power supply circle is completed to the fan. So the fan and light we have controlled connected to a relay, and relay is getting the signal from your board. Okay, so this is just an overview about the environment, simulation environment that you can use. So you can take various components. I have some models which I developed earlier using Wi-Fi and all, but because of security reason now they have removed the Wi-Fi. Let me see if there is available. I'm not sure whether it is still available. Must be in the gallery. Somewhere in the gallery it must be there. If you go to the gallery, you will find many old circuits. You'll have to search for it. Or if you just search in the Google, okay, these are all 3D models. So wonderful 3D models people have developed here. See. So you can build an entire home, and you can fit your devices inside this 3D model, and then you can completely demonstrate. Or you can just get it 3D printed with a circuit into it. Make a flying insect. Put a circuit into it. So this has a particular, just like drones, it has a particular name I'm not able to recall. If somebody knows. So drones which are in the shape of insect, they have a specific technical name. If somebody remembers what it is called. Ornithopters, right. So ornithopter is the term. So you have the flying machines, so they are called as ornithopters. Just like quadcopters. Okay, so I'll stop this simulation part over here. I have given you an overview. and we have around 1 hour left. So I have to go ahead with the GSM and GPRS. That how, coming back to the hardware, how do you configure the hardware? So you have any other queries related to this part? So you can just explore this. The basic programs you can write here, test it. The only thing is that Wi-Fi and they have removed. Also, that's and due to Wi-Fi ESP also they have removed from the Tinkercad. If you want to make the corrections, you can always go to the circuito.io or Proteus is there. Proteus has everything, but it is licensed. Maybe you can get something. Right. Thanks. So coming to the hardware part again, let me share my slides. Okay. So the two very commonly used connectivity modules here are Bluetooth module and GSM module. GSM because it gives you the feature of sending SMS, then voice calls, and even GPRS it has, so internet connectivity you can use, because Wi-Fi is not available everywhere. See, people generally talk about Zigbee. So Zigbee is more used in case of the mesh networks, but it's a very costly protocol. It's a licensed protocol. There are many things. And nowadays for long distance, so LoRa is a very common protocol being used. So if you use a proper antenna and frequency band, so you can even provide a communication up to 500 meters or even more than that without the need of any backend network. 6LoWPAN is there, right? Low power wide area network, right? So many options are available. We'll start with the Bluetooth connectivity. You can connect your mobile phone to your hardware. So take the screen mode, slideshow. Shift. So the screen share is coming in between. Let me just shift it. Okay, so basic module is HC05, the most commonly used module, simplest one. It works on old Bluetooth before Bluetooth Smart was introduced. And you can just clearly see what are the specifications. Right. So 4 to 6 volt is a supply required here, 2.4 gigahertz ISM band. So all those who have completed their graduation, they must be aware. So we have a free bands that is called ISM band, and 2.4 gigahertz lies in that particular band. You don't need any license to use it. And that's why Bluetooth anybody can use anywhere. Operating current, a very interesting part, 30 to 40 milliampere, right? So it takes a current of around 30 milliampere from your supply. And that's why it is generally said that do not give supply to your Bluetooth module from the Arduino pins. Fine, because Arduino pins can give you up to 40 milliampere, but that's very risky. In case your Bluetooth module exceeds that value, so your pins will be damaged or entire board can get damaged. Right, so this is the current requirement. Range is very limited for XC05, maybe 10 meters, 15 meters or so. Oh, it's very low power. It's ideally works at maybe 1 dBm or 2 dBm, not more than that. Serial communication is there, USART. So it just has a TX and RX pin. So you need to connect it to 2 pins of your Arduino, either RX TX of Arduino, or you can use any GPIO and configure it as a serial communication pin. TTL compatible for other hardware. So that is the protocol. Frequency hopping is used here. So you can use multiple devices. Right, master slave. This is very important and very rarely used. Now, I'll talk a bit about this part. I don't know if those who have studied communication, they might be aware of it. So generally what we do is, in case of Bluetooth, there are 2 devices and they get paired to each other through a code and then they communicate. But when you are making an automation system, in that case, so you have a control station in one part, and then there may be many devices which need to be connected through one centralized control station. So how do you do using Bluetooth? Because Bluetooth will make only one-to-one connection, right? And that is where the master slave configuration comes. So you can configure your Bluetooth devices in the master slave mode, where there will be one master control station, and all other devices which you are controlling, so they will be configured as in the slave mode, and so master will be communicating with all the slaves in round robin operation. You can set the sequence, you can set the time, the frequency, at what rate they will be communicating, but your one master controller can communicate with multiple slave devices turn by turn, one by one in time switching mode. And this is how you can have multiple sensing nodes, and they all will be sending data to one centralized control station. So just like creating a star topology for a sensor network. So this is one very interesting feature of Bluetooth, and around 10 devices can be connected. But if you go to BLE, BT4, so the number is much more, right? This is very rarely explored and a bit difficult to configure. But if somebody is good in programming, you should try that, how you can control multiple devices from one single control station using Bluetooth. Then almost all the baud rates which are commonly used, they are supported by Bluetooth. 9600 is common, and then 115200 is another one. So these are the two common baud rates that we have. You can set the baud rate. Then another one is the advanced version is Bluetooth low energy. So it works at very low energy. Fine, and you can see it here. So 17.9 milliampere active mode. So it has a power down mode. So almost 17 to 18 milliampere it is taking. Earlier one was taking around 40 milliampere. But the advantage is that you have a sleep mode for this BLE chip. So 8009 is one model. It works on this IC mentioned here. So if it is in a sleep mode, so then 60 microampere is the current consumption, which is very, very low. Almost say 1000 times low compared to milliampere. Fine. So this saves a lot of energy because your devices are battery operated. So if your Bluetooth module is on, even if it is not transmitting, it will keep on consuming some power if it is in active state, right? So there is an option to take it to a low sleep mode, power down mode, and that's why it is called as Bluetooth low energy. So it consumes very low energy. So it does not mean that it is transmitting low energy, because if your transmit energy is low, then your coverage area will be reduced, right? So you need to have more transmit power for a longer coverage, or you can change the frequency. So this low energy means it is consuming less power, and that is governed by the current. So your voltage is not the deciding factor. Voltage is more or less similar for most of the devices. So that depends upon the semiconductor. But current is the major factor which decides that how much power your device is consuming. And that's why all the batteries, they are always written in case of mAh. So milliampere hour. So how much milliampere of current you can draw for how many hours. So that is the capacity of a battery. Fine. So this is Bluetooth. Otherwise, all basic features of this HC05, they are available in BLE, but BLE has this additional feature that you can put it to a power down mode. The pin configuration, very simple one. Just have to connect 5 pins. So ground pin, VCC is there, connected to Arduino, and then TX-RX. You can take any 2 pins. There are particular marked TX-RX pins on Arduino or any controller that you use. Otherwise, you can connect it to digital pins. Then there is the enable pin, right? So there is the EN pin you can see here, and this is used connected to any particular pin on Arduino, digital pin. State pin is not generally required. So once you make these connections, so this is how your Bluetooth will look like. This is actual image, front and back side. So on back side, it is all marked, and you have to connect it. Right. So all these connections are made here. So you have 5 volt, then you have ground, then pin number 9, 10, 11 are being used here for key, TX and RX. Fine. So you can just whatever module you take, check for the pin configuration, and then accordingly you can make the connections. So if you want, you can take the screenshots of these. Otherwise, things are available online. It's not something very unique which I am telling, but how to do is the difficult mode. Right. So now once you have made the connection, so you have to configure it initially. It's not that you just plug it and you can use it. It's not plug and play. So there are some configurations which are to be made, and that is the important thing. You will get a lot of codes on internet, many applications of Bluetooth with complete code, but till you do this configuration, you will not be able to use it physically. So this people generally do, they get an Arduino or any ESP32, take a Bluetooth module, do the wiring, copy paste the code, and then they say it is not working. So that's because you have to configure it. So most of these hardwares need some configuration. So for configuration, we have to take it to a command mode. So normally it is in the transmission mode. So you have to shift it to a command mode. And what you do for that is it takes the AT command. You enter from Arduino IDE and serial monitor and send those commands to HC05. So that is to be done on Arduino. And then the program reads the output of HC05 and that's what you see. So that's how it works, that whatever commands you're giving through your IDE, Arduino, it goes to the HC05, then it is processed over there, and then the results, you can open a serial monitor in your IDE, and there you can see that what are the results. I'll show you the screenshots. Fine, so software serial port it is using, that is TXRX. To take it to the command mode, what you have to do is, you can maybe note down the steps, those who have not used till now. Right, so there is this particular pin, key pin. In some models it is written as key, in some other modules it is written as EN, enable pin. Right, so you just have to you connect this particular pin to a logic 1. Fine, so you have to connect it to a Arduino board. We have done that, and then you have to take it to the logic 1 so that it enters into a command mode. And when it goes to the command mode, we call it as AT mode. AT are the commands. So this is the default baud rate, 38,400 when it is in the command mode. Whereas in transmit mode, the baud rate is generally 9600 or maybe 1150, 200. Right. One very important thing which you must remember, that when you are taking it to the AT command mode, you must remove the VCC from HC05. Fine. So I'll take you to the diagram again. So you can see, so there is a red pin, the VCC pin, 5-volt pin, right? So just remove this particular wire when you are taking it to the command mode. So you make other connections, TX, RX, ground, and key pin, but remove this wire of 5-volt VCC, right? So after you remove this wire and keep other pins connected, so then what you have to do is, now you give power to your Arduino, to your controller, whichever you are using USB. You have to use the computer here because you will be giving the commands through Arduino IDE, which is running on your computer. So just connect your Arduino to USB port, and it should not be paired because HC05 is a Bluetooth module, so it should not be initially paired with any other device. You have to check it. Now there is a small button. I'll just show you the diagram once again. If you see this front screen, so at just where you have the pins at a corner, you have a small button, right? So once you're taking it to the AT command mode, so what you have to do is, do not connect the 5-volt pin, but switch on your Arduino board and then just press this particular button, small button, just press it, very small in size, just press it, and then you connect this 5-volt power supply. Fine, and when you do this process, your Bluetooth module will go into the AT command mode. Fine, so that is what is given over here. I have summarized it. You can take a shot of this, right? So make sure that it is not paired with any device. So your USB is powering your Arduino. Then push and hold the small button on HC05. Now you connect the 5-volt VCC to your HC05, right? And your LED will start blinking. And at 2 seconds interval, at a regular interval, it will start blinking. So when you see this LED blinking, it means your Bluetooth module is ready in the command mode, and now you can configure it. Fine. And if you open the serial monitor, so on the serial monitor, you can test it. Just type AT in the command mode, and you will be able to see a OK. I'll show you the screenshot. Maybe some other device I have a screenshot later on. But this is what you have to do. So I hope you have understood the process. So what you have to do is, your supply is not connected. Again, coming to the diagram. So your 5-volt is not connected. Fine. Power up your Arduino. Press this small button at the corner of your module. Now give this 5-volt supply to the Bluetooth, and then you will see an LED blinking. So there's a small LED here. That LED will start blinking. So that means it is in AT command mode. So then you can just open your serial monitor and type the AT command, and you will be able to check the response. It will show you OK. This OK message will be there on your serial monitor. So serial monitor is where you can in the runtime give the values or the commands, and it displays you the output. So it's a simple text type of window. Let me just show you serial monitor. I have it somewhere. I have a screenshot. Yeah, okay. So this is the screenshot of your serial monitor. Some part of it. Okay, so you have a text box at the top. Here you have a text box. You keep on typing, and at the bottom area you will see all the values or responses or the commands that you are giving. Right, so this is your Bluetooth is in the AT mode. So after that, so these are the various commands that you can try in the AT mode. So just you want to check what the specifications. So type AT plus ORGL, right? So this will give you the default settings. What are the default settings? It will take you to the default settings. Version you can check which version, which model you are using for Bluetooth module, AT plus version. You can change the name of it. AT plus name equal to, you can give any name. And this is useful in case of master slave or when you are having multiple devices. So how do you know that your message is coming up from which particular module? So for every module, you can give it a name. You can change the name here. There is a default security code, generally 1234, which is used for the pairing. So you can use AT plus PSWD password, this command to give any particular number, any 4-digit number you can mention here, and that number will become your security code for pairing. Right, so you should generally change a security code here. It is a secure protocol. Bluetooth 4 is quite secure. Baud rate you can change any value depending upon your application, to which devices you are connecting your module. So you can set the baud rate here to check the specifications of your devices. So just AT plus UART, you give the value and your baud rate will be changed. And then stop bit and parity bit, these are used. Standard we keep it like this if you're not using a particular parity. So these are the AT command modes which you can use. So once you connect your module to your controller, take it to the AT command mode, and then you can use all these commands to do the initial configuration. So main thing is you can check the version, you can change the name, you can change the parity security code, and then you can set the baud rate. And there are many more AT modes. You can just go to the documents of your module. Now the transmission part. So for transmission, what you have to do is now connect. Yeah, some query? Okay, so sending and receiving is, so you have the TX and RX pins, so they are connected to your Arduino, so that is used for the transmission. And on the serial monitor, you can see, you can always do a serial dot write, and whatever is being transmitted, you can check on your serial monitor also. Fine, and these are the commands: serial dot read and serial dot print and serial dot write. And so serial dot print and write, the difference is one is in the byte mode, other one works in your ASCII codes. That is the main difference. Otherwise, both the commands you can use. So one is slightly slower, other one is a bit faster in response time, but the difference is very, very less. You will not be able to feel it. Right. So let me take you through one example code. I'll open a Word file. If it becomes visible, or I'll have to stop it, the screen share. Can you see the diagram? Somebody please confirm.
No.
Okay, so I think I'll have to share the screen again. My example. Okay, too many windows. Let me just close some of the windows. Okay. Right. Fine. So this is one example. So we have used an Arduino, and then there is a simple DC motor. So there is a Bluetooth module, and then this is a motor driver. So all the connections have been done over here. And if you just take a look at the code quickly, it is very easy. Just increase the font size, zoom it a bit. Right. So some comments are there, how you're using it. Okay, so the motor is being used. These are the pins, pin number 3, 4, 5 for the driver, motor driver. That is connected. Then some integer state level is defined, one flag is defined. So these are the variables, depends upon the way you are programming, what kind of variables you are using. So in the setup mode, you have to define all the input and output pins. So 3 pins we are using. So these are required by the motor driver IC. So they all are the output pins. Fine. So then you set the baud rate, serial.begin 9600, and then it's just easy. So you initially you use this serial.available. So you have to check that whenever your Bluetooth module serial communication is available or not. So it takes it into the state, this variable, yes or no, this is Boolean, 0 or 1, it will read, and accordingly the flag is set. Then you give a command. So this code, what it does, that you have a simple mobile application. So there are 2 buttons for on and off. So when you press one particular button, it gives one message to switch on your motor, another button to switch off your motor, and then there is a direction also. So you can rotate it clockwise or anti-clockwise. So basically there are 3 buttons available. So you can make a simple mobile application. So there is one app called MIT App Inventor is there. So that is very commonly used. It is just a graphical interface, and using very simple graphical interface, you can make a mobile app, and you can add a Bluetooth module in your mobile app, and then you can just you have to define the pairing code into your app. So once your Bluetooth module is running, your circuit is running, you open your app, enter the pairing code, and then you just make 3 buttons. One button will be for clockwise, other button will be anti-clockwise, and third button would be to stop the motor. You just press that button, accordingly the command will be taken here. So when you use the app in your mobile phone, so through the Bluetooth of the mobile phone, a signal will come to the HC05 module, and that HC05 module will be taken through the serial.read mode, and accordingly it will check that which command is coming, whether it is 0, it is 1, or it is 2. So how you program it, that is dependent. So in this case, the mobile app has 3 options, 3 buttons. One button is giving signal 0, another button is giving signal 1, and third button is giving signal 2. So signal 0 means the motor will remain stopped. Signal 1 means the motor will rotate clockwise, and signal 2 means motor will rotate anti-clockwise. So just write one block, copy paste it, change the value. So flag is where we are storing the value which is coming for the motor, right? So this is a simple code. So main thing is this initial part, the serial.available, you have to use this particular part, serial.available, and then serial.read, and store it in any variable. So this state is just a variable name. You can use any name here. It is just a variable name. So if serial.available is true, then serial.read, this function will be called, and it will read your serial port, which is connected to the Bluetooth, and whatever value is coming, that will be stored in some variable. So we are sending integer value 0, 1, and 2. So that's why I've defined a variable integer type here and storing the value here. And then flag I'm changing in my if statements. Okay, so this is how you can use a Bluetooth module. So whatever operation you want to perform, so accordingly this code will be written. So coding is not a big part. The major part is that you have to make the initial configurations. You have to go take it to the AT command mode, set the baud rate, change the name, change the pairing code. Once all these operations are done, you just you can use some inbuilt mode. So there is another app called Blink, BLYNK. So this was some time ago free app, but now they have reduced it. So some features, it is a kind of a point system. So some points you get where some basic features you can make using that particular app. But if you want to make more complex apps, you have to purchase it. But that Blink app is mainly used for Bluetooth connectivity. Otherwise, you can just explore a little bit MIT App Inventor. So that is a very easy app, entire graphical. You can make small app with 3, 4 buttons, and then you can use it in your Bluetooth application. Fine. So this is about the Bluetooth connectivity, how we do it. It's very simple. Let me go back to the next part. Right. So another important interface is the GSM or GPRS module. So we have one single system, so which gives you the features of GSM mobile connectivity as well as GPRS for internet connectivity, and obviously a SIM card is to be used here. So you can see different types of modules over there, right? So these are the different versions of the GSM module. The one you see at the top, so this is more commonly used, another recent version. The name is SIM 800L. So with this particular name, you can purchase it, SIM 800L, right? So it is very small in size and it uses your micro USB, smaller SIM card, micro SIM. It uses this one. In the lower section, the one which you see on the exact right corner with the shaded background. So this is the oldest version, which we used to have with the 8051 or very old microcontrollers, right? So not much used these days. It had a serial port to connect, which we don't have nowadays. But the other one which you see, the two layered, so this is Arduino Shield for GSM. Right, so this is exactly compatible with your Arduino board. So this entire, we call it as a shield. So anything that connects to your Arduino board or any controller board to give you additional features, so it is called as shield. So you can have a Wi-Fi shield, you can have Bluetooth shield, you have a LoRa shield or any other. So basically expanding your one particular board. So you have a master card and then you have a daughter cards. Right, so this is Arduino has given its own GSM module. So it just sits on top of your Arduino board, and then you can make more connections on this. The one on the left side, lower part. So this is another version of this GSM module. So it uses the bigger bigger size SIM card, and it has a battery for a real-time clock, and then antenna can be connected like this on board. Okay. So these are the various options. So most commonly used is SIM 800L, or SIM 900L is also another option. So any one of these you can take. This is very small in size, and small SIM, micro SIM you can put into this. So you need to have a SIM, right? So one thing you should remember here is that whenever you are using a GSM application, so these are the commercial applications, okay? And if you are making a product which requires GSM connectivity, so one thing is you need a GSM for every module. Second thing is that since you are sending data, SMS or calls using a GSM module, so these are some commercial packages, right? So different service providers, they offer special packages for your IoT devices, or maybe for your automation embedded devices. So generally like 40 rupees, 50 rupees a month, but that is the recurring cost which you have to bear. So if you're building a big system and you have 10 sensor nodes, each one is having a GSM module. So that means somewhere around 500 per month will be a recurring cost of your project. So you have to include it when you are doing budgeting of your project. Right, so otherwise you will not be able to use. So it is not like some simple module, like, and you can put it for testing purpose, lab purpose, prototyping. You can use any routine sim, but once you are deploying a project for a commercial use, so you have to take a separate connectivity for that. And there are provisions coming up recently now that for IoT applications, so special type of SIMs are being used. So that will be entirely different network on a different frequency band, and separate SIMs will be there, which will be having a different sequence of mobile numbers, phone numbers, and they will mainly be used for the IoT applications. So these things are coming up, but not yet commercialized. Right. So this is the hardware of your GSM module. Now this is one basic module, SIM 900. So it is a bit bigger in size. Fine. So, but you have everything. You have microphone, you have earphone. So you can make the voice call. You put it connected to your controller, configure it, and you can use it as a phone. You can make the voice call because it has microphone and earphone sockets onto it. So a lot of indicators, serial ports are there. DC port is there. SMA connector for antenna. You can connect your antenna here. Power supply section, voltage regulator, UFL antenna is there. This is connector, right? So this is one part, and these are the pins for SIM 800L. So most of the things are quite clear from the name. The net, that is pin number 1, is where you connect your UFL antenna or helical antenna, I say. So two types of antenna are used, helical and pencil antenna. So helical antenna you can connect at this pin number 1. Then supply, reset pin, TX, RX for serial communication, ground, ring and DTR, right? So DTR is activate or deactivate. So you can put it into a sleep mode so that it consumes less power. So power is very, very critical. And GSM module, you should be very careful about power current consumption when you are using a GSM module. I'll show you the specifications. Right, so DTR is to put it in a sleep mode, and ring indicator. So whenever there is a call on this particular number, so you can read this particular pin as a ring indicator. So there is a pulse of 120 for 120 millisecond. You get a pulse. So you have to read that pulse to know that there is a call on this particular number. So there are some auto answering systems available, right? So what they do is they just read this particular pin and put it in a loop. So whenever there is a signal on this particular pin, so then you just send a call receive, you just activate that particular function. So these are the specifications. Quad band, most of the devices are nowadays quad band, so all the 4 bands it is supporting. Then any GSM network you can connect, make phone calls, voice calls, SMS, GPRS, even FM you can receive through FM. Now power, very critical. Please note that when your GSM module is transmitting, so it will be at a power of 1 watt or 2 watt, and the current required goes up to 2 ampere. So just see the last line. Maximum current drawn is around 2 ampere during the transmission. Fine. Otherwise, 60 microampere. Power down mode and sleep mode is 1 milliampere. Now, why this 2 ampere is important? See, we are supplying power to this GSM module, right? And that power is few volts. So you can use your Arduino 5 on Arduino. You have a power pin for 5 volt. So you can use that 5 volt to power up your GSM module. But the problem is the moment it transmits, it will draw entire current, 2 ampere current it will draw. And this will be so much of power that your board will be damaged, right? Another thing, you have a battery in your system. Now your battery is giving power to your Arduino, right? Because every time you will not be having laptop or desktop. So how do you power up your Arduino? So you connect a battery to it, or you use an adapter, right? So you have a battery which is giving power to your Arduino. You have a 9 volt battery. So Arduino requires say 5-6 volt, and you connect your GSM module to the same battery. Now what is happening when your GSM starts transmitting? It will draw away 2 ampere of current, and your Arduino will not be getting enough current, because both are connected in parallel. And what happens in parallel? Your current gets divided. Fine. So the moment your GSM starts transmitting, so it becomes a low resistance path, and entire battery current will go to the GSM, and you will not be getting any current in your Arduino board. Your Arduino board will reset. Your code will not work. And this is a very common problem, and with many devices. So you have to be very careful while you are making the power connections. So whenever you are giving power supply to any device from your Arduino board, so you have to be sure that how much current it will draw. And similarly, if you are extracting power in parallel from a battery for your Arduino as well as some other device, communication or maybe some motor, so again you will have to see that how much power that device is drawing from the battery, so that Arduino keeps on getting its minimum power. Okay, voltage is not the problem. In parallel, voltage will remain the same, but it will not be getting enough current to drive it. Right, so that's why you should always have, whenever you are using a GSM module, so keep a separate power supply section, or then you have to use a DC to DC converter, buck converter you have to use. Right, so these are the specifications. So 1 watt or 2 watt is the transmit power, and how much current it draws. You should always take a note of it. Antenna. So 2 types of antenna can be connected here. So there is a UFL connector where you can connect your helical antenna. You have to solder it. So this antenna will give you not much coverage, but fine indoor environment for testing, prototyping purpose, you can use it. But if you want a better coverage, proper functionality for SIM card, then you should use this type of antenna. So you have another connector at the top. So this is just, you don't need to solder it. So this is a wire, it has a specific connector, UFL connector. You just press it on this particular pin and it gets connected. So helical you have to solder, this one you have to solder, whereas this one, it has a special connector, you just press it and it gets connected. Fine. So it has a much better range. So it gives you better connectivity. Another thing about antenna is that whichever antenna you are using, you must be sure about the band which you are using. So every communication module operates on a particular frequency band, right? And your antenna should be tuned to that particular band. For example, if you are using a LoRa device, so that works on 433 in most of the US and European countries, whereas in India, we have 867 megahertz. Fine. So if you are using an antenna of 1800 megahertz band, it will not work with the 867 megahertz band. 900 one will work. So because most of these antennas are multi-band but not wide-band antennas. So you have to check the specifications that for which frequency band you require and whether your antenna is compatible with that band or not. So this is one way of connecting it. So you're using a battery and you're drawing power to this. Okay, so you have a separate source of power for Arduino. So this battery is only for your current. Now you can see there are two resistors connected here, and these resistances are basically for the voltage because your Arduino pin is giving more voltage than required. So you connect resistance to it and you just split the power, some of the current, and so that only the required current goes to the SIM. Okay. So this is how you can connect it. So TX and RX pin you will be connecting, and then 10K resistance is good enough for the one pin, and 20K that will go to the ground, right? So either battery or a DC to DC buck converter you can use to power up your GSM module. Right. So just have a look at these LEDs. Can you see the LEDs blinking?
Yes, sir.
Yes, sir. Yes.
Fine.
Yes.
So just read. So these are the three status that you can get. The moment you power up your GSM module, so these LED will start blinking, and just note down the frequency of LED, and accordingly you can find out that what is the state of your GSM module. So if it is blinking every second, that means the module is running, but there is no connectivity. There is no cellular connectivity. Fine. If it is blinking at 2 seconds, so our GPRS is connected, you can use the internet, right? And 3 seconds, that means you have made the contact with the network, whatever your service provider is, and you are ready to go with the voice and SMS calls. Okay, so this is the connectivity indicators. So just when you power up, just observe for some time that how they are blinking. So these are three situations. You will be having any one of these three situations. Then again, just like Bluetooth, you have 80 command modes here also. Okay, so some commands I've given you. So you have to add a library, software serial.h. So this is one library you have to add in the beginning of your code, and then you can create a part of it, software serial, my serial. You can create a function. So just give the pin numbers where you are connecting your TX and RX. So you have your default TX RX on your Arduino board, but whatever controller you are using, which pin numbers you are using for SIM connectivity, just mention those pin numbers here. Okay. Then in the setup section of your code, so baud rate you have to set 9600, and then another baud rate for SIM module. So there are two baud rates. One is between your Arduino board and your IDE, and another baud rate is for your board and SIM. So there are three different entities which are communicating with each other. You have your board, you have your IDE, and then SIM module. So for both of them separately, you have to set it. So my serial is the function we have created, which is a part of the software serial library. So whenever you call the function myserial.begin and or any other function myserial dot whatever function you have in this library, you can call it by this name. Right. So just do it, and then you will be going to the AT command. So these are some of the common AT commands. Open the serial monitor. So just type the AT, press enter. So it will show you OK. If you see the OK, so that means your GSM module is working fine. And then you can check the signal strength. So whether your mobile SIM card is getting enough signals or not. So AT plus CSQ. So that will give you the signal strength. So there are some numbers. You can see here 24,0. So the first number is the signal strength in decibels, dB. How much dB signal you are getting. So minimum is 5. Anything above 5 is fine enough. Fine. Okay. So depending on the antenna or connectivity which you are using, so that is the signal strength. Then 80 plus CCID. So that is the SIM card number. So IMEI of the SIM card. So that will be displayed here. So you can check the SIM card number that you have. Then CREG. So registration on the network, whether you are registered or not. So the options will be 3. You are getting 1. So that is on the home network. If it is 5, so you are on a roaming network. If it is any other number, that means you are not registered to any particular network. Then you can have a module name, ATI just type. It will give you that which particular module, which version you are using. Then connected to a network, COPS question mark. So that will tell you that what is the network. The name of the network will be shown over there. And if you just type COPS equal to question mark, then all the networks which it can read. So this is like when you do a manual network search in your mobile phone. So it shows you that these are all the networks available. So all the available networks it can show you by this equal to sign. And then CBC is the battery status, very important. So what is the battery status of your device, right? So it will give you the percentage in 93, the second number, and third number is actual value in millivolts. So 3.8 volt is what you are getting from your battery. Okay, so this is used in the programming. So you can use this command, and the output of this command, you can store it in a variable, and then you can make a check that whenever the battery level is going low, below a particular value, so you can generate an alert that your battery is running low, either charge it or replace it. Okay, or maybe it is not giving enough voltage to you. So you can always use these commands to perform various operations. Then, okay, this is another interesting thing. So this Arduino has its inbuilt buffer size. So whatever messages are there, so it stores in that buffer, and that is limited by default to 64 bytes only. Right. So if your message is bigger in size, so it will be either overwritten or rejected. So you can always increase the size of the buffer. Fine. So there is a command under software serial library through which you can increase the buffer size, and most of the modules they offer you up to 256 bytes of this. So what you have to do for that is you have to go into your Arduino IDE, and you have to look for a particular file. So these are the folders. So wherever you have installed your Arduino, go into that library. So there will be an AVR file, then library folder, then software serial folder, and then there will be SRC file, right? So under that SRC, just look for this particular line, RX buffer size. So you will see this statement, max buffer 64. So just add it and make it 256 or whatever value you want. So this is the file, and you can change the buffer size. So this software serial.h file you have to open, and then look for this particular line, and you have to make the changes here. So then save it, and again rerun your code, and your buffer size will be changed. Right. So this is all about basic configuration, that how do you connect, what are the specifications, 80 command modes, changing the buffer size. Rest is about the programming part. So you have SMS send and receive, or you can have your voice call. You can even make a voice call or internet connectivity. So all those things you can do. So I'll show you some part of the code. Let me open another example. I'll show you the code. Okay. Okay, so this is the code for SMS, that how you can send and receive SMS. So again, the code is not a problem. It is available online. You just have to copy it and then make the changes the way you want, and should be able to use it. Okay. So just include gsm.h. Then pin number, which pin number you are connecting. Pin number of your SIM. So generally for the security purpose, your SIM card has a pin lock, right? So if there is a pin defined, you should mention that pin number for your SIM card. If there is no pin, then you can leave it blank, just write as it is. So then we create a variable GSM access, and then another one for SMS. Then set up baud rate, initial message you can and give whatever message is to be transmitted. Then another variable, connected or not connected, to check the status. So while not connected, so you can give an SMS error that pin number is ready, or you can give an error message here. And if it is connected, then GSM initialized. So read serial. So that whatever is there in the buffer, so it will read that part. You can have an integer value and keep, as long as the message is coming, it will keep on storing it in the buffer. The new line character is there. So an array, entire thing is stored in an array. And serial.flush, clear the buffer. So this is a standard code for GSM module. So then you enter a mobile. So this is the initial setting. So, and if you want to send it to a particular number, so then serial.print, enter a mobile number. So the user will enter some mobile number. You can just read that number from reads.serial. Then you can show that number by print on the command screen that this is the number entered. Then what content is to be written. So just serial.print, enter the content. And then the user will type some message. So read serial, you will read that message, store it in a buffer, and then through print you can send it. So serial.print, so it will keep on sending the message at the number which was given in the beginning. So it's very standard code, simple code. You just pick this code and copy it in your IDE, save it as a file, and then you can run it. Right, so all these examples are available. So it's not a problem using it. You should be properly configuring your system, and any function that you want to use, any specific condition that you want to use. So you can add a loop over there that, okay, this is the condition in which I want to use. This is, if this is happening, then my GSM should be activated, and then it should, there should be a pre-stored message which should go away. So right now what I've done is, here the user is entering the mobile number to which SMS should be sent. So what you can do is you can straight away store a predefined number into your some memory or variable, and you can configure it that whenever the SIM module is activated, then the message is stored in another variable array, and automatically that message will be sent to this particular, you can say, the number whichever you have given. So you must have seen a lot of such applications. People come up with that, okay, you press this button and then an alert message will go, or warning message will go, and this will happen. So these are all some very simple basic things. So I think after going through all these documents, so you should understand that if somebody says that I have made a project and I am able to send an SMS, so please say that, okay, fine, it will take 15 minutes. What more? Right. So that is the purpose of and having such discussion, that we should know that which particular task is taking how much time. So if you give a project to somebody and he says that, okay, I will need 5,000 rupees because I have to use SIM card and do a lot of programming. So please tell them that I'll give you the code, just put it in your board. Right. So why do you need 5,000 for doing that? And people are doing it. For such small, simple projects, just copy paste from the internet and connecting a piece of hardware, people are charging 4,000, 5,000, 6,000. But things are there. I have not written this code. It is available online. Right. Similarly, I'll show you a code for voice call. So that's why anybody, when somebody comes to me that using Arduino, I make a project, I'll say that please keep Arduino aside and see if you can do it in embedded C. Okay, I'll share another screen. Right. So now this is to make a voice call. So again, the standard code is there. So header file you have to include gsm.h. So pin number for your SIM card, GSM access same. So voice call is one function here. the number you have to enter, to which number you want to make a call. Then you have created a buffer. Then baud rate is set. So message on the screen, voice call. You can even connect a LCD. Okay, I've not shown you LCD display. I'll show you one example where LCD screen is connected. Though I'll suggest that nowadays OLED is available, because connecting LCD is very complex. A lot of pins are required. In fact, 4 data pins are required for LCD connection, whereas OLED complete module works only on 4 pins, right? But still, I'll show you one example that how LCD is to be connected. So this is a standard code. You just have to, again, not connected, give an error message, or if it is connected, just start reading your pin, whatever is the phone number, and then read that phone number, and then length, check that how many digits are there, then call this function for making a voice call, and then the buffer will be created, a real-time buffer, and automatically whatever messages or voice is there, so it will start sending that voice and also receiving it. And then to terminate the call, there is another function, just call that function, your call will be terminated. So you can link all these things to the buttons. So one button will be to start the call, one button will be to stop the call. Basically, those buttons are just calling these functions. Okay. So this entire code is ready to use, and it works fine for any application. Right. So this is how you can make the voice calls using your GSM module and any microcontroller board. For LCD module, let me give you one thing for LCD. Let's see if I have an example of LCD. Okay, I'll go back to the Tinkercad, and maybe I have one example of LCD. Yes, it is there. Okay. Where is Tinkercad? So any queries in between if you have? So these things, actually, if I go into line by line code and all these things, so it will take a lot of time. So, but I've left some options open for maybe the next 2 days, where you will be having more hands-on practice on STM32, which is a better option. Okay, so this is one example, a similar automation system, but now you have an LCD also, where you will be able to see that what are the values captured by the sensors. So I just want to show you that how LCD is connected. Okay, so this is the LCD. So it has data pins. Let me go to the code. Right. So you have, whenever you are using an LCD, so you have to define that which are the pins you are using, right? So just some name, variable name has been given to the pins. Now PIR is connected to pin number 8, bulb is connected to pin number 7, temperature on A1, fan on pin number 10. So now we have defined the pins, and we have given them particular names, so that when we are using it on the function, then we exactly know that which particular device we are interacting with. So I've just given the name to these pin numbers, and now I will be using these names as variables in the functions. So all the variables have been created: minimum temperature, maximum temperature, fan speed, LCD, PIR state. Then setup is done. All the input and output pins are defined. Then LCD.begin. This is another additional line whenever you are using LCD. So you have to give the size. So this is a 16 character 2-line LCD. The LCD which is being used here. So you have to define that which LCD you are using. Then it's a standard code. So you are reading a PIR state from digital read. So if it is high, so your bulb will glow. If it is low, bulb will not glow. Similarly, temperature, if the temperature is less than minimum, the fan will be at slow speed, or it will be switched off. If the temperature is higher, the fan speed will increase. So some calculations have been done. Mapping has been done from 0 to 100 for the temperature. And then this is LCD. So LCD.print, whatever you want to print on LCD, you can do that. And then you can set cursor from where it will start printing. So that is for the set cursor. So initially you have to set from where it will start printing. And then whatever message you do right here, so that will be displayed on your LCD screen. Okay, so this is about LCD. So initial thing is you have to define which all pins you are using. RS enable 4 data pins: D4, D5, D6, D7. So 4 data pins are being used here in case of LCD. And let's try to simulate it. So you can see so many wires are required if you are using an LCD. Okay, so right now the temperature is 74. So if I just move it, so it is picking the value from the temperature sensor and it is getting displayed on your LCD screen and your fan is rotating. Activate the PIR sensor. You just move it a bit here. PIR sensor. So the light is on. When the object is moving, you come out of the range, LED light is off. So some delay is there. For that much duration, the light will remain off. If the motion stops, after some time, light will off. Right? Let me reduce the temperature. The motor is stopped. So I increase the temperature. Motor is slow. It is becoming fast. Okay, so this is automation, mainly using the LCD. So 4 data pins we have used here. Right, so this is LED's connection for LED. Then 4 data pins we have used, and then enable, read write pin, reset pin, then voltage, VCC, ground. Right, so this is how you can connect your LCD display. So LCD.begin you have to use. You have to define the pins, then write and read write commands to show data on the LCD. So whatever you write in the brackets, in the inverted commas, so the same thing will be displayed. Where is the, okay. So whatever you write in inverted quotes, so the same thing will be displayed. And then after that, you have a variable, then again the unit, and then you can go to the next line. Right. So let me see if I can change it. Okay. I'm in simulation mode, so I cannot change the code. Let me change the code a bit and see, run it again. Fine. I'll change this one also. Right. Okay, so now there are 2 lines, first line also and second line. So in both the lines it is printing. So the moment you change the code, it will show you the effect. The temperature is different, so it is reading in a particular range. So if I just change this formula, let us suppose I make it 1. So see, your temperature range will change. Okay, so your temperature range has changed. See. So it is going from minimum 20 and it is increasing up to 350. So entire range of temperature it is taking. And now it is printing in the second line. So whatever I've given here, I've changed the cursor. So the next part, the temperature it is printing in the second line. So first line it is giving the initial value, and second line now it is giving the temperature which is being changed. So because I've changed the cursor setting. Right, by default it takes in the first line. So this is how, it's a simple code. Things are available. You just download it, use it, and then try to understand the logic and implement it and make your own applications. Fine, so I'll stop here. I'll not go to the Wi-Fi because that's a bit more difficult. One thing, application building is as a thing. So there is one tool called as ThinkSpeak. I don't know how many of you must have heard, those who are working in this area. Think, THING, Speak. So ThinkSpeak is one platform where you can build your IoT applications. You can do the internet connectivity or cloud connectivity. Fine, so you can just download that particular app or check the online in your laptop, and you can configure it and then have a Wi-Fi module just like Bluetooth. You connect your Wi-Fi module to your controller, and you just have to enter a code just like Bluetooth pairing code. You have a Wi-Fi code for the pairing of Wi-Fi devices. Add the same code in your ThinkSpeak environment, and you have to create a display, user interface, and you can use the Wi-Fi connectivity. Fine, so I'll stop here because I think you have another session after this. So if there are some queries, maybe I'll try to answer.
having any doubt can ask here. So I think they understand all the things very clearly.
Fine.
Thank you so much, sir, for sharing your knowledge with us.
Okay. Fine. So thank you very much for listening to me for such a long time. Let's see, maybe we can have. Okay, there's something on chat box. Is there any specific programming? Okay. Any specific programming for Arduino? See, Arduino, the basic syntax is based on C language, right? But the Arduino IDE has its own libraries. So you just have to call the functions from its library, right? Otherwise, the language is based on C. Let me show you the IDE once again. Just give me a second. I think I have one Arduino board. If I have, I'll just connect and show you.
All the participants may put your questions in the chat box. If you have any doubt, you can put your question in the chat box or ask one by one.
I've got an Arduino, but cable, just let me see. I have cable. इसकी वो तार दो इसकी अभी मैं उससे लेके आया हूँ ना इसकी तार दे दो. So the Arduinos which are using they have different cables. I have one Arduino Nano, so it does not work with the normal USB. It has a different old USB connector. Just see if I can get. Till that time, I'll share the IDE once again to answer that question. Okay, so this is the environment where you do the programming. Okay, I got the cable. I'm just powering up Arduino Nano. Right. So in the morning when I opened it, so it was not connecting to any board. So there was no board. I'll just click board info. Okay. So Arduino, I'm using Arduino Nano. So I'm going to select it from here. Right. So it automatically shows what processor I'm using, Atmega 328P, then port, I'm on COM3. Right. So once I've set up this code and any particular code, I type it. Let me copy paste some code. Though I don't have the sensors here, but yes, at least it will compile the code. I think I'll take 2-3 minutes more before the next session. One example I have. Tinkercad is open. No. Okay. So I'll just take one piece of code and put it in IDE. Right. So some code I've written over here, and then what you do is you have this one button right check mark. So this is to verify or test your code or compile the code. So it will ask me to save. Let me save it, whatever name it is taking. Right. So now it is compiling. Okay, in the meantime, one more important thing you should note down that whenever you have your TX and RX pins connected to your Arduino, then your program uploading will not be done. Fine. So always remember that whenever you are uploading a new code to your Arduino, the TX RX pins should be removed because these both are communication pins and both have different baud rates. So when you're uploading your code to the Arduino, so you are communicating through the USB port, right? So if TXRX is also connected, so there will be a conflict of communication and your code will not be uploaded. Fine. So compiling has been done. So it will tell me that how many bytes are there, how much memory I have utilized, how much memory is left. So sometimes if your code is very big in size, so it will give you a memory error. So you have to optimize the size of the code. So once your code is compiled, then there is a right arrow. So just click on it. It will say that upload. So when I click here, so my code is getting uploaded to my Arduino, and now my Arduino is ready. Uploading. So it is getting loaded in the controller. Okay, still working. You see if serial monitor is running or not. Not yet. Okay. So once this copy uploading is complete, if there is no error, so this will be complete, and then you will be able to open the serial monitor. So this is the program which I've shown you. The same code which was there in Tinkercad, exactly same code you just copy and put it in your Arduino IDE, and then it will be running. So this is standard C code, but the thing is that the file which you save, it is not a .c file, it is .ino file, because it is using a lot of inbuilt libraries of Arduino. So that's why it does not give you a .c file. But yes, you can always export a hex file from this. So there is a process you can just check online, and in the preferences you can add more libraries. Like I do not have ESP32, so there are options from here. You can just add your further libraries. You can do the proxy settings. So that all is done in preferences. It is not getting uploaded. So it is giving some error, so it's not getting uploaded. So otherwise, once this uploading is complete, so then you can check the serial monitor and you can see that. Fine. So this is about the programming. So it is using basically the C programming part. Any other question? Yes. Any other question?
No, sir. I think.
Okay, fine. So thank you very much. I've taken a bit more than what I was supposed to. So thank you for this session.
It is very interesting, and the time is not a concern in this actually.
Okay.
Yes, sir. Definitely, our participants have gained a lot of knowledge from your valuable talk.
Fine. Okay. But again, I'll still say that use this Arduino only for the prototyping, but never use it for final product, because no industry is going to accept it. And even if it is nano, because there are a lot of limitations in terms of power or in terms of current capabilities. So try to work on the controllers where you can get a standalone module. For Arduino Nano, you can get a QFN package and you can put it, but then you need then crystal or then oscillators and other circuitry along with that. Fine. So just select your controller properly, which you can put to your final product also, if you want to go to a product level. Thank you very much.
Sure, sir. Sure.
Thank you, sir.
Thank you so much, sir.
Button. Now the FTP participants can leave and the value-added courses students can remain.
Okay, so I would like to invite Dr. Pallavi Gupta ma'am, Associate Professor in Electrical, Electronics and Communication Department, to deliver an expert talk on basics of IoT and entrepreneurship. Over to Pallavi ma'am. Just wait for a while.
Hello students, good afternoon. Today I'm here to share my views on IoT, Internet of Things. You might be hearing about IoT a lot commercially also, and of course in this this value-added course since last 2 days, and it has become now mandatory for every one of you to join. Right, so I'm just trying to share the PPT, the basics. Before I share, I actually want to know that what all do you understand by IoT? Yes, students? Anyone? And till this time, that what is an IoT? Anyone?
This is the first time I'm hearing about it.
Ma'am, IoT stands for Internet of Things. It is used in the modern area to connect machine to machine devices and creating smart home, smart cities, hospitals.
Okay, it is machine-to-machine communication. Yes, good.
And URLC,
Okay.
MMC. Yes, ma'am.
Mm-hmm.
Machine type. And ma'am. And this type of things. Smart cities,
Yes.
home buildings. Yes, ma'am. Medical, in medical.
Okay, smart city and all.
Yes, ma'am.
Okay.
Basically, ma'am, all that.
So why it is so popular? Why it is getting so popular? Yes, why
Ma'am, actually it is very easy
why
to
IoT
use.
is getting so popular?
Ma'am, we can connect easily device to device by
It's very
simple
easy to
coding.
use. Great.
Simple coding, ma'am, and large area of connectivity, ma'am, and ma'am, security, purpose, ma'am, due to security, it has large
Security
level of.
is yet to come. In IoT, security yet to come.
Yes, ma'am. And ma'am,
Ma'am, we can save time, save energy.
See,
yes, ma'am. Less level of sensor is used. No, ma'am.
Yes, we can save a lot of things.
Small device of a small level of sensors can use low cost sensor, easy to be ma'am IoT related things, ma'am.
I think
Yes,
exchanging data with other device and system over the internet. We can exchange a lot of data over a device, like over the internet, because it's like connected with embedded with sensors, software, and other technologies for the purpose of connection.
Okay. Yes, fine. So all this is IoT, right? We have a basic understanding of IoT, and that is very good. Because it not only comprises of the IT part, it the basic thing is hardware there, right? Hardware with the programming skills, right? Our programming skills in C and embedded C will help us make an IoT solution. It is popular as, of course, it eases the way of monitoring and controlling the solution to the solution. Like if I want to monitor a specific area, if I want to monitor a specific machine, if I want to monitor this specific functioning or a specific process, it can easily be done using an IoT. the monitoring part, the human fails, because monitoring part, we are not able to monitor continuously. Even if we form a pyramid of monitoring the process by a group of people, then the people have issues related to the constraint with respect to time. They'll have their lunch time, they'll have their off days, and they'll have their, like, the process is not that automated. If we complete work to the machine, the complete thing becomes very easy to handle, right? In basics of IoT, if I just see the definition, right? So we are connecting billions of devices, right? We are connecting billions of devices, and what we are trying to do, we are trying to make things communicate. What happened was that there was only computational devices which can talk among themselves. Computational devices means mobile can talk to laptop or send the information to the laptop or my computer systems or my laptops or my tabs. All these are computational devices. Okay, they are made to communicate. But if I say that I'm talking about the chair, I'm talking about the light, I'm talking about the table in my room, I'm talking about the door in my room or in my house, so they are not the computational devices, they are just the things. But now attaching the embedded system to them, and also the embedded system, which is actually the data system, and it has some sensors and some actuators. Like I can just put the wheels on the table, right? And may ask to move that table, may I ask to move that table forward, backward, left, right. It's just putting up the wheels in that table and then connecting. Wheels will act as actuator and then connecting the sensors to it. Okay, as I enter the room, the table should come of me. That process I can make. I can make things communicate. That as the door is opened, the table comes in me, so that I can put up my things together on it if I am going to demonstrate my lecture. So this is possible. So here I'm not using any computational device. Here I'm using only my electronics. I'm only using the system. Okay, embedded system, the system on chip. Okay, the understanding, the programming, whatever you have studied right now, the Arduino. Right, you can have node MCU, you have Wi-Fi points, which Wi-Fi ICs which could directly be connected to the Arduino. Right, and from there you can through internet you are going to communicate with those devices. And this actually IoT is not a single technology, right? It actually comprises of many technologies. Okay, it started with RFID. Now it involves the nanotechnology, the sensors, the smart networks, the big data, and lot many areas. You can use one technology and one or two technologies, or you can use any technology under it. The basic thread or the fundamental of IoT is creating solutions to the existing problem, and these solutions should be smart enough. These smart solutions to existing problems. If I can do that with the combination of technology and of course the internet, then I'm saying that I'm making IoT purposeful. I am creating the IoT solution for a given specific problem. Maybe if I want to monitor the traffic, if I want to monitor the waste which is collected in my society, if I want some kind of device which I could wear on my hand and the data should be collected on cloud. So such things if I could make, then I'm saying that I'm handling the IoT. Of course, the machine-to-machine which was already there. Okay, then industry automation was there. There were industries which were running where the output of one of the machine was the input to the another machine. Okay, this was already there. This was happening. There was no human intervention. Only one where the industries were fully automated, we could get the output without human intervention. But what about debugging? Now, what happens? the machine-to-machine communication is there, but there are few with those communication. There are the problems like if some part of the machine is not working properly, or one of the machines cuts down completely, or it's already giving vibration. One part of the machine is already giving vibration, which can give rise to the complete stoppage of the production of a product. So can I give that alarm? Can I monitor the functioning of that part using a system or using a technology where I can stop that loss to the that okay, one part of your machine is giving some vibrations which were not there yesterday, or which were not there day before yesterday. There's some new changes are there. A special type of vibration is coming out of specific motor. Means the production is going to halt because one of the machine is not working. So such is the capability of that giving those monitoring systems. Of course, it can give the solutions in the form of monitoring, but also the control. Okay? But the basic thing for IoT is monitoring. Of course, the control. If we talk of home automation, if we talk of irrigation facilities, if we talk of there are many using an IoT already in the market, right? So all these things, when put down together, it's an advantage. It's a edge towards the M2M connectivity, right? So like I visited few of the companies here. Companies, what they were stating that we have machine-to-machine communication, we are getting things done, but the problem is I want to find out the complete production which is being done on the portal in my system. I want. Okay, so what do I have to do? I have everyday production. What is the raw material which is getting in, and what is output which is getting out? Everyday reading should be there in my system. So what am I going to do? I am going to create IoT system. Okay, wherein I will be providing the electronics at the input where they're putting up some raw material which can sense the amount of input they are putting in. And at the output also, I'll just a sensor which is going to count their product. And those values will be sent to the from that cloud. I can send it to the required person system, or I can divert it to that system. He wants to look up what was my raw material and what was the production. And of course, I can also give the amount or the waste which was created. So now the data which was all in the registers, the everyday register was made, every day the entry was done. Okay, now it could be on the cloud, and they could take monthly report, they can take out weekly report, and they can find out, or they can have better services. They can look for like of man force, what kind of force they are using in their industry. So IoT has made the things to that level. Of course, what one of the students told that there are millions and billions of sensors which are associated. I'll show you. This is the expected. Trillions of sensors are going to be there, billions of smart systems, and millions of applications are going to be there under IoT. Like today also, there's so much need of the commercialized product in the IoT, even for the system, smart home automation. There's so many companies which are already in for the home automation. What does home automation comprise of? Anyone? Can you give me some ideas of home automation? What do you understand by home automation using IoT? The part of home automation. Yes, Himanshu. Vipul, any answers? What do you understand by home automation? No answers? Sarfaraz? Sarfaraz Hassan? Anyone? Abhishek Deepkriti? No one is at home automation? Virendra Tiwari? Nobody knows about home automation, right? Am I audible to you all? मेरी आवाज आ रही है?
Yes, ma'am. Yes, ma'am.
Audible to you? Students, hello?
Yes, ma'am.
Yes,
You
ma'am.
are.
Yes.
Okay.
So what happened? I'm not getting any answers.
I think home automation is, like any other automation system.
Nobody knows about home automation. That is not possible.
Control all electrical devices using smartphones.
Ma'am,
I
like
want
home
it.
automation,
I
we
want it
have
from Vipul
products.
Kumar.
Okay.
Okay.
I want it from Vipul Kumar. Vipul Kumar is there in the class. Vipul Kumar is there in the class. Francoise. Umesh.
Yes, ma'am. Yes, ma'am.
Yes, Umesh. What do you understand by home automation?
Ma'am, I'm Francois.
Home automation.
Francois.
Yes. Francoise, you. What do you understand by home automation?
Ma'am, when we take the expression home automation, we have two different words there. We have home and then automation. So home automation here, when we take home, here in this context, maybe it relates to like our daily activities inside our apartments or homes. So like home automation, so we are using automation for it. So like using electronic devices such as sensors and some microcontrollers and so on and so forth to automate some of the tasks that we have in our apartment homes.
Okay, fine. Like home automation includes controlling of the light, right? Right, I can, whenever I enter the room, the light should switch on, and whenever I leave, it should switch off. It's one of the monitoring and control, right? It will decrease my electric or using the smart meters in the home, right? Or smart locks, these smart CCTV cameras. The information is coming up to me who is there on the gate. So all this using the IoT technology. And home automation is the most popular thing which is arising right now, of course, after the medical devices. Right, so in which anything which I want most, because anything which is related to our finances, we directly have to pay the okay, the electricity bills we have to pay. We have to pay, if we are not controlling the light inside the house, then the electricity bill we are going to pay. What if we generally forget to switch off the geysers, we generally forget to switch off the air conditioners, we forget to switch off the lights. So what happens? The thing is going to run forever in our, which is until we are going to switch it off. So the IoT can help in there, right? IoT can, the smart meter, where they could give us the messages, okay, this unit of electricity you have spent on this day, in this month, or in this, you could have such messages in your phone. So where you could understand that, okay, how much electricity I have already used up, Because what happens while using these things, we don't remember that how much we are using and how afford. Right? So that may this IoT technology can give us the control over there. So you can see lot many applications for IoT, like first air pollution, snow level monitoring, landslide and avalanche prevention, earthquake early detection. Just I gave you the example in case of machine to machine communication, the water leakages, the radiation levels, the explosive and hazardous gases, supply chain control, NFC payment, intelligent shopping applications, smart product management, and lot many applications which are related to IoT. I'll show you. IoT market share. For all the applications of IoT which are made, the industrial IoT has the highest share. Like lot of research on here, maximum research, and then in healthcare in IoT, and after that in and then in security. Retail means what type of control? Like monitoring of the inventory, right? Small controls you have, like if you go to a store and if you're picking up a small thing, then and putting up it in your basket for getting it billed, then the inventory itself is getting checked. There were 10 pack of these things and now it is 9. So such type of things are feasible using in, and of course the security. Lot of money, lot of business is being created in the manufacturing of or the industrial IoT, and nowadays the healthcare. Monitoring is involved, like in corona pandemic. Okay, you cannot monitor a patient while being in the room. So how are you going to monitor his vitals? So IoT can help. Earlier we were in ICU, what were there? Connected directly to the patient's bed. But now can I transfer those values outside that specific area where my doctor may be more safe? So I can do that using IoT. A lot of students have made, a lot of researchers have to get this thing done, and there's a lot of scope to do this. Right? There's business potential into this IoT. IoT takes you directly to the product. Directly make the product of an IoT based product, based on one node, based on two nodes, based on nodes. You can make a product and you can bring it to the market, right? Bringing that product to the market, you have to initially have to create the prototype. Once you will create the prototype of that system, if I say that you have built in specific device which could be put down in your, it gives you the picture of the person who is coming on the gate, sitting remotely in the office or in your class, who is coming to your door. So if you have made this product, you can bring it to the market, and after bringing it to the market, you can just sell it to your clients. So you don't need a very actually, since IoT is the combination of all the existing technologies, so you don't need a lot of technical stuff. A very basic programming of the controllers and the basic understanding of the available sensors get you make the product. But while developing the product, there are a lot many things. While going into the entrepreneurship, lot many things. Okay, I'll show you those things also, the business models and the ethics which are included. Okay, I'll just share those things also with you. I think I have conveyed the basic of IoT to you all. Okay, what it is actually the Internet of Things, where I'm connecting the multiple physical to the cloud. They can send the information to the cloud. They can communicate among themselves. They can data, and that data could give an achievable or understandable intelligence to solve the problem. Right. I'll show you. I'll talk about some business models and ethics in IoT. Once you are making a product, or once you are thinking of entrepreneurship in IoT, then the canvas of the Alexander Osterwald. Okay, if you are thinking of bringing, it's actually the this model or this canvas is actually fitting to any of the product which you are bringing in. Okay, it is more into the picture right now. IoT is very close to entrepreneurship. A small solution you provide with the small electronics. You don't need to have understanding of electronics. You just need to have know the Arduino programming and transferring that programming onto that board, and using that controller you can make the product and send the information to the cloud, and that information from the cloud or mobile phone. The blog I have shown in the previous slide. Okay, in that blog on IoT, and I have shared how you can do basic programming of IoT in Arduino and connect to the cloud and get the information on the mobile app. All that information is there on the blog. Whenever if you want an IoT, you can go back to that blog and just, it's 5G communication blog. Right, so here the canvas. So what is this canvas? What are the key parameters which you should take care while going for entrepreneurship into this IoT? First is the key partnerships, key activities, key resource, value propositions, the customer relationships, the customer segments, the revenue streams, and of course the channels. So this is the canvas of your entrepreneurship in IoT. Going to form a product. Once you have made the prototype, on your own or with the help of, how are you going to take it to the market? Who are going to be your key partners? What are activities which you have to identify? What is the raw material? Key resources is the raw material. Where are you going to get the raw material from? What are the value propositions? Value propositions means tell your client, how are you going to sell the things? That okay, once you put my things on, once you put my device, happen, you can view which person is coming at the door remotely in your mobile phone. This product and launching into the market, you have to give this proposition to the client. Then he'll say, okay, I have same category. Then you have to keep the price competitive. The value proposition means of the product by which we are going to sell that product in the market. How are you going to make the customer relationship? Right? What are the channels which you are going to use? Customers align each and every point, like revenue streams. How are you going to generate the revenue? Of any of the system, we need some money, right? And money, if we are getting investors to put in the money, how are we going to get it back? What will be the revenue system? This is one of the very important factor which one has in mind. Value propositions, I already told you, this is USPs for which the positive points about your product by which the product will become sellable. The customer segments. Whom are you going to sell? Are you going to sell this to the villages? sell it to the metropolitan people, you're going to sell it to the service class, you're going to sell business people. Whom are you going to sell your product? So you have to identify those things. Names, identifying value propositions, identifying customer segments, and then customer relationship. That are you going to give some guarantee, you're available, your timings. When are you going to interact? The channels. Channels are the ways of reaching the customer segment. How are you going to reach your customers? You're going to give the ad on the television, you're going to give the ad on FM radio, digital marketing you are going to do of your product. How are you going to reach your customers? What are the key activities which are involved? Like things to be done before you actually product into the market. Okay, what machinery you require, what is the force, take a task force, how many people you are going to put it up together to get your things done, to get the raw material from. And the key resources are the raw material itself. Okay, what is which is being used? Is this available in the ample amount in the given place where you are trying to work upon? The key partners. Whom are you going to make the partners? Who are the investors? Who is going to invest? Because they will invest in terms of the stakes in your company and they will become your key partners. Cost structure. What cost are you going to put up with your device? Okay. Now, after seeing all these points, there are actually 9 points altogether, you have to for your entrepreneurship, for your product. This product should have all these, or you have to put down together, you have to put it in your diary before actually starting your system. That do all this. If you are leaving one thing or the other, then it's going to create a lot of the end. So this Alexander's Oswald canvas will help in it's not only in IoT, it's actually in any of these things are important for any of the product if market, right? And since we are talking of IoT right now, so these models means some of the models that Internet of Things companies have used and consider some of the parameters. These models relate to canvas are as follows. How are we going to sell the things? What will be the model of business? What will be the business model for selling our prototype? Not only prototype, you things in the domain of IoT. So what are the models? The first model is make thing and sell thing. This is the easiest one, for which I have given you right away, that you are making one of the product and then you are selling it. This could think of, depending upon the cost and everything, you can do this. Another thing is subscription. Subscription, you can have this model of entrepreneurship where what you are doing, you are creating a solution, putting up in a society, or you're putting up into multiple house and you're giving them subscription, say for 5 years. Paying initially for the product and then they will be paying for your services, and once the time is off, you can take your product and right, or customization. You can create a specific product which is already there in the market and you can customize it according to the customer. That becomes your customization. Next is be a key resource. Like you are very good at hardware, say you are very good at programming the controllers, you could be a key resource for an IoT product. Debug their issues. If you are very good at say electronics, basic soldering and connects. Okay, you can do that. You could be a key resource to a industry where it is actually this is by this way you can actually be the IoT empire, providing the infrastructure, the sensor networks. So what it is, another way of creating the business. That what you are trying to do, you're creating a sensor networks. The sensor network, what the sensor network does, it collects the data specifically. You can collect the data of the specific area, maybe temperature, humidity, rainfall, any of the data, or maybe at home, the number of persons who are visiting, any data, right? Or if it is related to the e-waste collection, then that could be the data related to the how many waste is collected from my house. So all this data can be created, can be sensed using my sensor network. I have put down a sensor network in a specific area, and the people who want to give the who want to use that sensor network can ask for my permission and pay me for that given network or for the use of that data. So that becomes the sensor network. And finally, the taking of the percentage. Whatever thing is happening, whatever product, if it down, if you are helping to develop that, not develop that product, but to develop the product, then you can have a percentage for that product. All these models, all these business models, now they could be used for the IoT product, which is already into the market, or you want to bring a new product with a new USP. That is, you're very much welcome. If you want to excel in one of the fields, like making the sending the data to the cloud app, or working in the controllers, or working with the hardcore electronics, then you are very much welcome. Providing, if you could provide a complete network, you could buy a network and provide a network for us, get the data, and that data is sellable. So all these business models could be used in IoT. When talking of these business things, when talking of creating of the product, one thing very important is the ethics. In IoT specifically, it comes into the picture because the data which is being collected could be like, if I want to find out the visitors in my house, it may also give the data that at what time I am entering the house, at what time I am exiting the house. Some regular patterns in my behavior could be there. So then, if I know, then actually I should have that understanding that I am not going to share that specific thing, work on those part which is going to hinder the privacy of a specific person or specific organization which they don't want to share. So here, this is very important part. So whenever I talk of the business models and business canvas, I always talk. So ethics is, technology often creates new possibilities with one hand and new problems with the other. Inherent is the physical thing produced are environment concerns, the carbon cost on the manufacture and the raw material required for its complex electronics. Then there's a moral question over whether the workers tasked to construct it are treated fairly. Okay. Taking complex and putting them into the fabric of the world and your personal possession allows sensors to read sensitive data, combined with the ability to data through the internet. It becomes possible for companies to monitor their customers through their telephones, electricity meters, or their air freshener, like what WhatsApp has just shared, or the Facebook. They share all our data, but they're sharing all the data. Many of the countries don't let them do so. Right. Similarly, monitor their citizen locations in ways that might not be obvious. This raises questions of transparency and privacy, and the issues of a right to have access to data that concerns us. I just now gave you the example of me visiting my home. So as technologists, we don't have concerns as prophecies of doom, but as a reminder to consider our responsibilities while we are engaged in designing and building our to delight our customers and bring us profit or amusement. We have also touched on how the technology of the internet can act as counterbalance to its own potential flaws. The widespread sensors and powerful processing can lead to better mitigations. The accessibility of the technology permits crowdsourced sensor networks, which tips the balance of civic power. Make their own informed decisions about issues that concerns them. I may not be knowing that what my data is being sensed by the sensor network, which is being placed by one of the companies. Right, comes the responsibility of that company that how my privacy is not hindered, and it does not. Hence, security is also one of the fields in which the students can excel themselves to improve their of being the key resource person or being the key person in the various IoT products which are going to the market in the coming few years. So this is all from me. Any queries, then of course I'm here to answer. I'll be happy to answer them. If you have any queries, then I'm here. Any questions? We have talked of the basic product lineup, and then we have talked of the business model, business models, and of course the important parts which we have to take in, we have to put in moving forward with the product, or if you are moving forward to be an entrepreneurship with an IoT product. Models could be there, and a few ethics. This was all from me for today. And you can of course see my blog for some basic, of course it is part of the syllabus of some UG course. So it's there if you want to look up of data which I've shown you right now, or you want to know programming of IoT devices, it's all there. Any questions? If it is there, then it's fine.
Any queries from the student side? Do anyone have queries?
Thank you, ma'am. Thank you for patience.
Thank you, ma'am. Thank you very much for your valuable information which has been shared with the students. I think students will come up along with many new projects with IoT. Thank you, ma'am.
Okay, definitely.
Thank you, ma'am. All students must join tomorrow value-added courses sharp at 10 a.m. Okay, thank you.
Thank you, ma'am.